So maybe they're going to get us up on stage at the end.
Yes, yes. I'm in touch with him also now. He's going to do a conference.
He's doing it. I'm Wendy Hall. I'm speaking now. And Jack Goose is the digital enlightenment.
Okay, what I'm going to talk about one place working on it, we have a building to get her assistant for this
Yeah. I worked with her for many years. So.
She was there for 6 or 7 days. She's nurse. Half an hour. And she was 2 hours.
But I think she was fascinated.
You want to take a look at foundation.
Hello, Peter. You're on. Anytime you want to get started.
I think it'd be a good thing.
I think we should start again. This is a much simpler session to chair because there are two speakers, and I know those two have superb self-discipline, so there will be no problem. The first person to talk will be Bob Kahn. I don't think I need to give much of an introduction to Bob. More or less everything to do with the first half of the subject of these things, the infrastructure for the internet, was first of all designed and put in by Bob with some help from Vint. So, and anything else to do with using it, like voice, satellite, video, was also things he first of all initiated when in DARPA. So with that very short introduction, Bob, would you like to talk about identifiers, data management, anything else you want to talk about?
Okay, can you all hear me? In the audience, is that okay? In the back, can anybody hear me back there? Okay. So thank you for that nice introduction, Peter. I might point out we're starting 10 minutes late, so I'm going to take the liberty of assuming we can push the 10 minutes to the end because we both have fairly lengthy presentations, I believe. But try to go as fast as we can. And what I'd like to do is essentially talk about an architecture for managing information that in all candor really started from some work that Vint and I did back in the 1980s. I'm sure Vint remembers it, but at the time we were trying to free people up from having to be with their nose to a keyboard, to a screen and fingers on a keyboard 7x24, and we invented this notion of mobile programs. We called them NoBots at the time, and it never really took off because we did it at the time when the very first Morris Worm had come out and people were worried about programming by other people coming into their machines. And so we split that apart. Vint had left by that time. We broke it into kind of a static part where the pieces were presumably fixed even though they could all be mobile in principle. And we call that the digital object architecture. So I'm going to describe that architecture for you briefly. Some of the work that we've been doing to try and make it more convenient for parts of the world that have been fighting the battles of, control and who's in charge for a long time. I know this is a fundamental issue because virtually any industry group that tries to get involved in this would like to start out by essentially owning, controlling, managing the technology themselves. This is a topic that we're very familiar with because in the early days of the internet, when we started it, most people didn't pay too much attention. I remember a lecture that I gave at the National Academy in Washington once, and it was one of these Intel or Westinghouse talent searches, and they had about 1,000 people in the audience, and one of the young ladies got up to say, "Thank you very much for the internet, but we have, one question." And it makes perfect sense when you hear it that a 15-year-old lady, who's very articulate and the spokesman for the group, would ask. And she said, "How did you manage to convince all the governments of the world to let you build the internet?" And the answer was, at the time, with the exception of a few of us who thought it was an interesting idea, everybody else didn't think it was going to go anywhere. And I suspect the way that we will end up developing architectures that are managed in the public interest that really satisfy all these different needs is if they somehow emerge. I don't think any one company is likely to promote it on its own if it's purely commercial. I don't think any one government can do it. It's unlikely all the governments of the world will jointly support it. So I want to give you a flavor for what it is, what it can do. I think it's a perfectly good choice. In fact, it would be my preferred choice for dealing with the interoperability issues and security issues for the Internet of Things. But before I jump in, I just want to make a few comments about even the term. I mean, a thing can't do anything if it's not able to interact. So instead of just talking about things, I'm talking about sort of interface-enabled things. We had things very early on in the ARPANET. In fact, the only things that were connected to it were big computers. And they didn't become interoperable. They weren't actionable until they had interfaces that people could talk to. It was one of the major contributions to that. It was not only building the net, then it was involved on the protocol side, building the interfaces and the protocols that allowed those things to talk to other things. And it's fundamentally a very similar problem today, with the single exception that the scaling is much larger. And when you think about the internet protocols themselves, I think there is very little in the history of technology development that has continued to operate over the scaling factors that we've seen in the internet today. I mean, since we started that work back in depending on your timing, let's say roughly 40 some odd years ago, the amount of bandwidth has gone up by a factor of about 1 million. The amount of CPU speed has gone up by, again, a factor of about 1 million. And for the same amount of money, you can buy 1 million times more storage. If the internet continues for another decade, which I see no reason why it won't, it'll be a factor of close to 1 billion, or maybe 1 trillion. It's very unusual for technology to be able to scale over those kind of issues. And the reason it did was because the internet protocols were a level of abstraction. They were not about the technology that it was interconnecting. It was about the protocols and procedures to allow anything to be connected that was connectable. And when you get to managing information, that's the same approach that I think we need to take. We need to find a way of talking about information, how to interact with information, about how to manage it and the like, independent of the technology of the day. It's surely going to change. Database systems will evolve. We may have something different from databases in the future. The kind of computation will differ, and we need to be able to respond to that. And so what I'm going to talk about is an architectural approach that for me is roughly the same relationship to the information as the internet protocols were to the things that the internet actually ended up connecting. So the three issues I really think are most important to focus on are: one, interoperability. We'll have different kinds of information systems all over the place. And we're really not talking about interacting with the things so much as we are about information about the things. So if you want to get information back, it's going to be some process, some interface that produces it back. If you're going to activate something, it's a process that's going to activate it. This is the Internet Redux, and the only question is, do we want to work with the same low-level protocols that are currently enabling connectivity to manage information, at a higher level? Security is another critical issue. I think it needs to be implemented intrinsically, and as you'll see, this architecture supports that based on PKI, but it's not required that PKI is there. Could be some other protocol or some other method. And oftentimes we want the information to be persistent in some way, and get more into that. But records need to be kept. You may want to go back in history to see about things. If it's medical information you're dealing with and devices, you may want to see the evolution of those devices and the information that they provide. So we're really talking not about the things, but information about the things and the actuators and the like that are manifest by the interfaces to those things. If we look at the ARPANET originally, the addressing in the ARPANET was all about the wires. So we had 16-bit identifiers, and they were broken up into kind of a packet switch part and a host part. Essentially, a machine was connected by a wire to the ARPANET, and you did addressing by saying, send this to essentially wire 17. You'd actually do it by saying, packet switch 6, wire 2, but essentially you're identifying the wire. And the 16-bit identifiers were fine in that day and age because when we started, all we had were the big mainframes, and they were very expensive, and you couldn't have very many. When Vint and I started working on the internet, we said, look, we need lots more addressing, and so we doubled the size to 32-bit IP addresses. And at the time, it seemed pretty clear that that was going to be more than enough almost forever. And we broke a 32-bit address into a part of 8 bits worth for network and 24 bits for machines on that net, because we were thinking that we might have, maybe 1 or 2 major nets in the US, maybe 1 in Europe, and then the Ethernet came along, and within a span of 6 months, all of that was overtaken by events. When the web came along, they did addressing by virtue of a combination of an IP address, or oftentimes a domain name that you resolved into an IP address, coupled with a file name. And that's the way most people use the web today. The problem is that many people are aware you get these errors that come in. You can't find the thing anymore, the file doesn't exist, the machine doesn't exist. And if you're dealing with information that you want to persist for very long periods of time, you really need something that is not tied to a temporal phenomenon. And that's part of what this architecture enables you to do. In fact, for those of you who subscribe to scientific journals, most of the major journals use the technology that I'm going to describe and have been for something like 1 or 2 decades. So this is not new technology, it's not new ideas, but it's evolving in new ways every day, just like the internet is still evolving some 40 odd years after Vint and I started it. So the kind of identifiers that we're talking about in this architecture are ones that don't tell you any information themselves. In fact, many of the people that use them generate these identifiers with cryptographic strings. So there's no guarantee, or there is a guarantee, that you can't find anything about. So you have to resolve these identifiers. And what is really critical about what I'm going to tell you is not the identifier itself, but the means of resolving it. Because once you have a good way of resolving it that is standardized, you can resolve any identifier within this resolution framework. So it's not about the identifier, it's about the ability to resolve identifiers going forward. And furthermore, when you resolve them, you can resolve them to all kinds of meaningful information, like locations where you can find information in the internet. So it could be 100 different places if you pre-positioned it. It could be information to authenticate it. It could be terms and conditions for use, all the kinds of things that are relevant in both business contexts and personal contexts as well. So I think one of the things that I really want to focus on here was this whole idea of having this architecture at a higher level. So let me give you some of the experiences that I've had with this architecture in particular. In 1986, at the National Academy, it was decided to reset up something called the Computer Science and Technology Board, and they wanted to understand what the agenda should be going forward. And I had proposed that they take a look at the internet and see what the implications might be for society broadly. Vint and I had just started CNRI, and we were in the process of working with the National Science Foundation to actually manage the standards part of it, which is the IETF, as you know it today. And the decision was made at the Academy back then that this was viewed as our proprietary technology. They could not spend time focused on the internet because this was considered CNRI's proprietary technology. And we said, no, look, this came out of the government. It was funded by government. It's an open architecture. The interfaces are public. It's intended for everybody to be able to use it. 2 years later, the US government funded the National Academy to look into the role of the internet writ large in the country, and perhaps even broader than that. And suddenly they said, okay, we'll consider it in the public interest. This digital object technology has exactly the same characteristic of it now. Some groups are now saying it's proprietary to us, and yet everything about it has the same attributes that the internet did before in terms of being an open architecture, defined components, standard interfaces. In order to make a complex system like that work, in the case of the internet, there was one thing that had to be managed carefully, and that was IP addresses, because if anybody could just generate their own, you wouldn't know where you were routing. It's possible with any system people can do workarounds, and we know what some of them are, but it's the function that an organization like ICANN provides that enables the stability of that internet going forward. You have a similar situation here, which I will describe. The lingua franca of this architecture is something we call digital objects. You've heard about that from other people, including Peter this morning. This is a defined term as far as I'm concerned because it really means it's kind of structured data with a unique persistent identifier. It's a set of sequences or sequence of information that's tagged in ways you can understand it. And these objects have an interface protocol, which I call, I guess, let's see if this works, DOIP, the Digital Object Interface Protocol. The components of this, so with this interface protocol, you can actually interact with these digital objects directly, or parts of the digital objects. So if you had, let's say, a medical record somewhere, or a thing that had an interface to it, a DOIP, for example, then you could ask detailed questions about that medical record or that thing, like what was my cholesterol reading, last week, or did I get my MRI back? Is it posted in the system? Or what was the temperature reading in such and such a room in Vint's house on such and such a day or time of the day, if you could get access to it. So security is important, but the ability to deal with the information directly is what's important. So you're not talking about dealing with a wire and then hoping you talk to something at the other end. You're literally talking to the information itself. So what are the components of this architecture? Just like if this were the internet, I would say you got machines, and you've got networks, and you've got these boxes in between, which we called gateways at one time. Now you call them routers. And at that level of explanation, it's a 5-minute discussion as to what the internet is. It belies all the complexity, to be sure, and it's still evolving. But at the level of this architecture, this is about as simple as it gets. You have repositories that are basically means of depositing through a defined interface, as DOIP, digital objects and accessing them, all by means of identifiers. That's really important because if you have interfaces that are all identifier based, you never have problems of trying to re-implement it when you have some new idea. I mean, it's something like 20 years now that we've been trying to really get IPv6 well established, and we're not quite there yet. DNSSEC was yet another thing that we're still working on. Whether we'll ever get there ubiquitously, don't know. But if the interface just supports identifiers, then you never have to change the interface, or at least not for a long time, till we have a better idea. But you simply create more objects. Objects that consist of actions, objects that enable you to target particular things. The second thing are registries, and it turns out that that's important for several reasons, of which the most important really has come up in spades in the big data concepts. It doesn't help for somebody to say, here's a terabyte of big data. You need to know something about what's in it. And unlike some of the traditional search engines that can go out and scrape web pages and find links and all that, it's hard to go scrape terabytes of data. You don't know what's in it. There are no easy ways to get to that. And so knowing how to type the information turns out to be critical. And one of the major uses of these registries, is to deal with typing data. So this is of a certain type. Those types are going to be defined in domains, and you want the experts in those domains to say what they are and what they mean, programs that can provide certain functions, ways to describe them in different languages. That's what the registries do. And then resolution systems that, or at least a mechanism that's powerful, that can take identifiers and give you state information about the things being identified. Now, one of the things I do want to make very clear is this is not in competition with the current internet at all. That is, everything I'm about to tell you is totally compatible with the current internet. You can use the domain name system. It certainly relies on the current internet architecture to move the data around. It simply provides a way of dealing with information in a way that we didn't have the hooks and handles to do before. So we have in this architecture a data model for what a digital object is. It's purely open architecture in the sense defined interfaces and protocols. I mentioned that you can have direct interfaces with these digital objects and their elements with identifiers and PKI. It is designed to enable long-term maintenance of this information, so you can have persistent storage, you can have short-term storage, and this is all independent of the technology of the day. So technology might change, a million or a billion times going forward, and these principles should still apply because it's at that level. Some other terminology. It turns out that this was something I was asked to present at an ITU meeting a number of years ago, and there was actually a framework description that came out. It's a very high-level description, but it covers the essential elements of this architecture. And just to describe it in the following terms, when I first was describing this, I described it in fairly low-level detail. And there were multiple objections from people who were there that said, well, my company has technology that does something similar, and my company has technology. And so we kept escalating and abstracting what I was talking about to the point where it became more like a kind of a tone poem. We ended up calling it a framework. But if I had gone and gave them a presentation on the internet back in the early 70s, they would have said, no, it's too much detail. That's not what we do. We don't want to take it in from outside anyway. We need to abstract, and when you're all done, you might have come out with a conclusion that interconnecting computers is a good idea. It's not quite a standard or a reference. Maybe one level down, they might say protocols would be relevant to achieving those objectives. But it took very detailed suggestions and popped it up to a very, very high level. So it's a framework. The actual documentation of some of the early parts of this were actually published as RFCs through the IETF, and we've committed to reissuing them through the IETF in the future to keep them apprised of the changes that have been made. But when we went through that process, there were also people that objected to the term digital object for whatever reason. And it ended up that the consensus was we should call them digital entities. And really, there was a defined term as to what an entity meant. It was anything that had a separate and distinct existence that could be uniquely identified. And so we ended up using that terminology, but from my perspective, digital entity and digital object are really one and the same. We use them interchangeably. And the other thing I want to convey is that in this model of the world, everything, every resource, every user has an identity of their own. Now, some of those can be anonymous. You can have an identity, but you can't pin it to anything in particular. But without an identity, this is not easy to operate. You want the ability to operate anonymously, though. So that's sort of built into this as part of it. So the particular data model is, again, machine and technology independent. These repositories just have all their access by means of identifiers. One identifier might be for the action to be taken, which could be compiled in the repository software, or it could be something that's resolved to find out what's the digital object that has the instructions or code to actually implement it. You may or may not want to do it on the fly if you've never seen that before, but that's all part of it. But the important thing to keep in mind is that a repository itself can be a digital object, and a digital object can contain other objects. And if we ever get back into the world of mobile programs, which is what Vint and I started with years ago, every one of these things can be in motion. When I grew up, we used to have these trucks that came and served ice cream. They kind of drive through your neighborhood. And that's a kind of example of a mobile serving of a resource. You could have a repository that shows up on your machine, you interact with it, and it goes somewhere else. Or it could be fixed and stable at one or more other locations. So things with interfaces, that's what I want to talk about. I'm not prepared to talk about a thing as a piece of paper all by itself or a thing as a piece of plastic. I'm talking about things that you can interact with, that you can add things onto them that support the standard kinds of interfaces. You can send them requests and commands via the interface. You can get access back in some form, all digitally. And all of these interactions are by the use of identifiers. So you have to compile it, just like everything in the internet basically ends up with IP addresses in the final analysis. The users aren't doing all those comparisons. It's programs that are doing the right conversions at the appropriate time. So every one of these interfaces will normally be able to support accessible metadata, and that'll differentiate them from anything that doesn't have such interfaces. Not much you can do with something that doesn't have those interfaces. So I mentioned earlier that the earliest things that we had were computers, and that by giving them digital interfaces, they became network accessible. Today, I think the whole idea of taking information in the form of digital objects with unique persistent identifiers is really the essential element, in my view, to creating a workable network of things that can scale and evolve. These interface-enabled things can be viewed as digital objects. It's not the way the manufacturers created them, but they can be seen that way within the system. And these requests can be coming from other interface-enabled things, as one of the topics that Peter talked about earlier as well. So specifically, security may be required on every transaction that's taken place. These DOs may need to interoperate with other digital objects. And here's an important point. In today's internet, we often have limits on the size of things. Email systems that can't handle attachments that get too big. But in a DO-enabled world, I think we need to assume that we can have small amounts of data, large amounts of data, and so the ability to interact with these things needs to be based on the assumption that we're essentially managing data in potentially large quantities. So maybe a sensor that generates a small amount of data, but it might hold it for a long period of time before it lets it go, and so the aggregate of all of those small amounts of data may be large. It may be something that generates a large amount of data, but you can't ship it over the network right then for whatever reason. You may need to hang on to that. So the interfaces need to essentially deal with this information flow as if you're managing an information system with large amounts of information right in the first place. So let's see, I want to talk about identifier resolution. So I've resolved this one. So the system that we have, we call the identifiers handles. It's just a term that we use. Digital object identifier is the more generic term. But what I want to focus on is not so much what those identifiers are, because they can be generated from many different parties. They could be IMEIs, which are used in the cell phone industry. They can be social security numbers, license plate numbers, cryptographic strings. The question is always, how do you resolve them? And so when we first developed the system, we didn't expect too many folks, but it very quickly became apparent that the people who were creating identifiers wanted to keep all the records for that themselves. If it was a bank, they wanted to keep the equivalent of the catalog for the bank records. If it was the government, they surely would want to keep their own. And so we broke the identifier system into two parts. One that would identify the party that was doing the resolution and keeping the records, and the other one being the actual record itself at that particular party. So if you see on this chart, there's here's a user interacting with the system. So this is the handle system, as it were. And there's a part called the Global Handle Registry, shown as GHR. And that's the registry that keeps track of all the local systems. And so if this local system over here actually had the record you need, the way the user would know to ask it is it would first ask the global registry, that would tell, go ask this guy, and then this guy, if it had the record for that identifier, I mean, the identifier may not exist or might have been a bogus one, this is the only place that will be able to answer it credibly. What does a local handle system do? Well, we were worried about scalability. So this local handle service is going to have one site that does the administration and then a lot of mirrors. So you can have multiple sites. They could be geographic sites, but we worried about scalability. And every one of those sites can have a different configuration. So here's one site that might have N machines, and here's another one that might have 2. The very first one that we had that involved a large number of records, I think, was Los Alamos. They had like 600 million records that they had developed for physics information. And so what they did was they built one of these sites that consisted of something like a dozen workstations. And they literally, the records got spread across them like spread spectrum. And so when you resolve the identifier, it would hash it into one of these buckets. You'd be able to get the identifier. And you could then replicate that with one big machine somewhere else or as many machines as you want. So what I want to convey to you is that, that within this architecture, the critical component is this global registry, because otherwise you'd have to know where all the local ones were and go ask them all. It's terribly inefficient. And second of all, that the system is absolutely designed to be scalable. We know of no limits on what could be done within the bounds of the technology of the day. So we're thinking 10 to the 30, 10 to the 40th kinds of objects just right from the get-go, and maybe it's, you know, it's the square or the cube of that, or some bigger number in the not too distant future. Now, what a handle looks like, this is just a simple case. It's got a number at the front, a slash, and then something at the end. The something at the end is whatever identifier system you want to use. It supports Unicode, so it can be anything you can represent that way, foreign languages, whatever. And the part that's to the left of the slash is what we call the prefix, and that particular thing, with the exception of one or two cases, are all numeric. And the reason we went down that path was to avoid some of the trademark conflicts that we have within the DNS. So you don't have to have people worrying about whether the semantics of that means something. We just give out numbers. So the original handle system documentation was actually published as 3 RFCs a little over 10 years ago. We're going to, whoops, yeah, so those are the right numbers. And we're going to update them shortly. This framework description in ITUT recommendation X1255 essentially enables this to be adopted by other countries around the world. It got buy-in through the standard external approval process. And we have, since those were first published, made a number of changes to accommodate what we saw the needs for this to go forward in the future. And I'll give you some sense of that in a moment. But one of the things that we were asked to do back a little over 10 years ago was to build a bind interface into a handle server so that you could actually do DNS resolution, which we did. And then we were asked by the National Science Foundation to work with some other countries around the world to essentially get them to buy in, and then to get mirrors. And that was all, it's all worked out very well. We've got a number of mirrors around the globe of the global registry. So we do all the authoritative inputs into it, and then it gets mirrored around the globe. And so far it's working just fine. So this is what the system actually looks like. This is what I think of as a repository, but it's really defined by this interface protocol. That's how an external user would see it. They don't see what's in here. So here are all these digital objects. They've got, you know, various attributes and elements to them. There's this logical external interface, and so everything takes place by this protocol, which is all based on identifiers. Nothing else takes place. There's a connection that you get set up with whatever the protocol of the day is. Then you can ask this repository to validate itself. Since every resource has an identifier, then you can send it a nonsense string as a user, ask it to encrypt it with its private key. With its identifier, you get its public key from the resolution system. You can validate it so you know you're talking to the right place. So if this were a medical record or a device, you might not even want somebody else to know what the request was. You could then validate this ahead of time. And if it checks out, then you submit your request using the protocol. That system may want to verify you, like if it is a medical record, it might not want to be disseminated except to people who are allowed to get it. That allowable list is, again, identifiers. And those identifiers could be for a group, like, you know, your family or your doctors, or could be an individual, whatever, or a combination. And so that's the check that's made going back, again, with a PKI interchange in the reverse direction. So, and keep in mind what I said before, that even though you see all these digital objects in here, this whole thing really is a digital object in its own right. So you can have access controls and all the kinds of controls for any of these on the whole thing itself. So now I want to say a few words about metadata. It turns out this is actually a far more interesting topic than I had ever thought it would be, but and in a lot of the discussions that we're now having in the Research Data Alliance, which was set up, I see Chris Greer is in the audience, and some of our counterparts in the European Commission, Australia, were involved in setting this up. They're very interested in big data and how you manage particular research data sets. And it turns out it's the information about those data sets that's actually more critical than the data itself. Because if somebody just gave you a bag full of a terabyte of data without knowing what was in it, you probably wouldn't do much with it. So what is metadata? Well, you know, in jargon fashion, I would say data about data. That's not as helpful to me as you might think, because I never liked the term internet being described as a network of networks, because it was all about the protocols and procedures. But more specifically, as I said over here, it's really helpful information that lets you navigate through an information space. Fundamentally, it's about making assertions. So this is a more detailed description. These are some of the assertions. They can be about identity. These can be assertions about the provenance of the information, who created it, maybe where, when, who can view and access it, what's the resource about, how to interpret it, in what stage of the life cycle is it, technically speaking, and maybe structure and representation. How is it formatted? How is it encoded? And so forth. This is fundamentally what metadata is. It allows you to understand what it is about the data that you're talking about. Now, one of the things that we've done is make available all the software that we've developed. It's all been really intended for open source access by the community. So if you wanted a repository, you download the repository code. Well, it turns out that somebody running a repository wants to know what's inside of it. if you're running a registry, you probably need a repository in order to keep the metadata records. And so we've just recently merged the repository and registry components, and you can download it from the corridor.org site. It's, again, completely open source, no charge. And this is a composite of the two, and we think that that's something that many people might find interesting to use. Selected applications are really across the board, really started out in the publishing industry. They actually set up a foundation called the International DOI Foundation that the managing agent actually lives in Oxford, England. In the US, the movie and cable TV industries decided to make use of it. They set up their own organization called IDER, the Entertainment ID Registry. The Research Data Alliance is using some of it and trying to deal with large data sets, in particular for typing and type registries. There's another entity that's gotten set up to deal with legal entity identifiers that's based out of Basel, I think. Of course, the IoT and various things about it, like this architecture is really helpful in dealing with counterfeiting and the like. I believe in China there were something like 500 million things on the shelves that were put into the marketplace in the last 6 months of last year. They may very well have a 2, 3, 4, 5 billion this particular year. And so I have like just two more slides to go. I want to talk a little bit about administering the Global Handle Registry. This is a problem that anybody in ICANN will know in spades, because the problem that we had was, as long as we were doing the administration, we found other countries in the world that were not willing to make use of the system if it relied on us alone. And so after many discussions that started out in the US within the government, and it goes back to more than 10 years ago, finally the decision was, after we went through different alternatives, including the possibility of other countries wanting to take it over or the ITU wanting to take it over, that if we set up a foundation, a nonprofit foundation in Switzerland to do the management of this architecture, that would be acceptable. So what it does is it takes responsibility for both enabling multiple parties to do administration. So instead of just us, you can have different parties. We now have essentially 3 of these administrators. We call them multi-primary administrators. There were originally 4 designated, but there are only 3 that actually signed these agreements. With 1 more that's made its intention known. There are 2 or 3 others that want to become part of it. I suspect that there will be a dozen of these in the next 2 or 3 years. And that's how the support for the foundation comes, because these folks each pay an annual fee to the foundation to keep it going. This foundation then credentials these. It does all the signing. There was an issue of, if you didn't have a party like that, who decides who can be the next RA, who can do the signing of all the credentials and so forth. So this is a foundation that was set up in January of 2014. So it's going on 2 years now. It's actually located in Geneva, Switzerland. It's got an international designation. It had an initial 8-member board of directors that's now, after consultation with the board, it's gone up to 10. 5 of those are actually from Europe, 2 are from the US, and the other 3 are from other parts of the world, 1 from China, 1 from Russia, and 1 from Africa. And we think this may be pretty stable for a while, but it can grow to as many as 25. And so in addition to taking responsibility for overall administration of this global handle registry, not the actual handle records, those are all maintained by other parties. It also supports outreach activities, and including pilot projects to help with awareness. We're looking for, funding, maybe from some of the sovereign wealth funds, other foundations, corporations to help with that. I suspect we'll have probably a dozen administrators fairly soon. So that's the nature of this architecture in a nutshell. I think it's a very basic kind of thing because it doesn't pin down the details. And I think, as far as I'm concerned, there is no information service, whether it's the service that a device requires on input or output, or a large information system, that this is not applicable to, But just like the internet itself, the fact that you can interconnect things doesn't necessarily make it useful all by itself. You still have to figure out what you want to do and how do you want to do it. And that's where the opportunity is for all kinds of folks in business, in government, in the public sector to tackle in the years forward. So thank you very much.
Well, so you see from that end how this is a very important part of the infrastructure for the Internet of Things, which makes it extremely relevant to the whole subject of the symposium. But the next thing is the data. We've had references to the data. Now we will see Wendy Hall, who is probably one of the experts on big data and everything to do with its use, how it could be applied, and so on. Wendy, again, introduce yourself a little bit as to who you are, why you are well qualified in this area. And incidentally, Wendy is one of the very, very few dames of the British Empire to show the general appreciation for what she's done in this area.
Thank you, Peter. Thank you. I have qualified my title with something about web science because I wouldn't claim to be the world's expert on everything about big data. I work with big data a lot, but in the context of the web and the internet. And that's what I want to talk about today. Like everybody else, I'm very humbled to be here with all the giants of the internet, to be asked to be on this platform. And that was a fantastic talk from Bob Kahn about how we can manage the data going forward. It's something I've been meaning to learn about for a while, and I now have had a masterclass in it, and we'll talk later about that. So some of the things I'm going to say will resonate a lot with what Bob just said. So I need to move on because I'm standing between you and lunch, which is always a problem. I'll try and say things. I'll whiz through some of the pictures. I want to tell you a story before I start talking about either data or the IoT. And I always put this slide in my talks because this is where this is the basis. The internet was the basis for all my work for the last 20 years. Working, of course, with Tim Berners-Lee on the web and how the web was built on top of the internet. That's his proposal that he wrote in 1989 about how we can manage information on the internet using this new idea of hypermedia and linking, and based totally on the ideas of the internet and the network effect, the connectivity of the machines, and building a hypermedia information layer on top of that. And now we're at the data layer on top of that. And this is where my talk and Bob's talk will come together. Tim's proposal was very much about linking documents, but in the right-hand corner is the semantic web of his proposal. That's the linked data, which was always part of the original vision, but got lost in the noise for a while because it was hard enough for people to get their heads around linking documents or using the internet in any way, shape or form, let alone worrying about linked data. And linked data is harder to do than linked documents. So this sums up the last 25 years, right? This slide is updated for me by an expert. He's got his PhD now, so I'm not quite sure what leverage I have to get him to do this slide for me. But basically, that's the last 25 years. I could talk for 30 minutes, an hour, a whole day on this slide. How it all started, and of course, so if you can't read it at the back, the red line is the blue line rather is the number of hosts. It's all taken from public data sources. Number of internet hosts. The red graph is the number of internet users, and we use that to talk about the scale of how the web has grown, and by putting on top of it things that happened in the web world and other worlds, the technology world. So things like the dot-com boom and bust all took place before we got Wi-Fi and broadband. So it was obvious it was going to go bust because the technology wasn't there to enable us to do shopping on the internet. Right? It was the World Wide Wait in those days because it was all too slow and nobody had computers at home. So all sorts of stories. Google didn't emerge till 10 years after Tim put the first website up in Christmas 1990. We had to build a web before we knew how to build a Google, is the thesis. We had search engines before that. They weren't as powerful, and they were really like catalogues, lists of where to go to look for interesting home pages and some rather hit and miss search information retrieval. Google needed, this is all really one big experiment. We are living through an experiment. There are other ways this could have been achieved, right? A global hypermedia information system. And I say to the students, so what if Tim hadn't given that away? What if CERN had charged a license for the code? Or you said about things could have been different with the internet. We could have been paying per click and that would have put an economic barrier in terms of what we were trying to do. And Tim's thesis was always either everybody will use this or nobody will. So we're going to connect the world or not, it'll be silos and it will not achieve its full potential. But then, of course, it builds on the network effect. And once you get the giants that emerge, like the Googles, and then as the web became more interactive and we started to be able to write to it as well as read it, we get the social networks emerging, like Facebook and Twitter and so on. When they become big enough, when they go viral and enough people start using them, then they become effective monopolies. And that is a really interesting, the fact that this has been founded on the principles of open protocols and standards, free to use, a neutral network, free access to the point of where you get to the information, which you then may have to pay for. So it seems to go against the trend that actually we end up with these huge monopolies. And of course, the Facebooks of this world would love everybody to just live in their world. Right? They don't want people to connect outside of Facebook. They want everyone to stay in Facebook. So I sort of think of lots of analogies, but like a rubber band where we stretch it out and then it comes back again and then it's going to go out again. And Tim's big thing at the moment is re-decentralization. I'll come back to that. So I could talk for hours about that slide, but there's lots of videos of me on the internet. Just look on YouTube of me talking about this slide because I use it a lot. So I need to move on. To cut a very long story short, of course, we have moved through the web of documents, we are in the social networking phase of this whole ecosystem, and we have emerged into a world of data. And of course, it's very incestuous because the technology and what we do with it, whether we're companies or government organizations or individuals, creates data. And then you have we also have the means to analyze that data because we have bigger and faster computers and we use the power of distributed computing, and it all feeds on itself a bit. But for sure, it's changing so many aspects of our lives. The original vision from Tim was linked data, the semantic web, the idea that, and this is where I begin to link with, excuse the pun, what Bob was talking about, because of course Tim talks about in the web, in W3C, it's URIs, universal result, everything gets a URI, a universal resource identifier, and then you use some sort of language like RDF or XML or whatever to link two objects to say they are related to data objects to create the web of linked data or the semantic web. And that means that machines, of course, can interpret that in way. Machines aren't very good at interpreting documents. We're good at that, but machines are really good at interpreting and inferring knowledge from data. And this is where you get all the plus points of the generation of new knowledge that we get from analysing this big data, and also the downsides of the security and privacy issues and the fact that there are organisations in this world, both governments and big companies, that know everything about us. Right, so you've got the yin and the yang of this world, and it's up to the likes of us to help governments and companies steer their way through this morass. Open data was one of the ways that Tim talked about, got governments and other public sector organisations to open up their data in order to get people to think about data on the web. With Nigel, my colleague Nigel Shadbolt, they set up UK's Open Data Institute, which has been one of the big movers and shakers in this field, and linked open data is even more powerful than just open data. And as I said, that's tipped us into this world of big data. And of course, not all big data is about what happens on the web, right? There's lots of, the astronomers have big data about what's happening in the heavens, and the climate scientists have big data about what we're doing to the physical planet, and the chemists have big data. But my particular interest is the big data that we generate by using the internet through the web. Or other means, I guess, but because we have to think about the whole app world as well and where that's going. And the thing I'm going to introduce into this conversation that nobody else, I don't think, has really talked about up until now is I can't think of the right grammar, people, right? This only works because we people use it. And any of this only works. The internet was a layer of machinery that was enabling function, but the web works because we put content on it. And when we were trying to, we being, I think, did I put the slide in? I can't remember. Myself, Tim, Nigel Shadbolt, Danny Weitzner were thinking about why the web of linked data wasn't taking off. This was around 2004. We were at a web conference in New York, I remember it, and it was all, Tim was saying to us in the bar as all these good conversations happen, I can't understand why people aren't putting data out on the web. And so we started to look back at how the web had evolved, and we looked at that graph, and we started to think about the fact, we ended up calling it web science, think about the fact that there's this new ecosystem, and this is what I wanted to introduce into our discussions today, this ecosystem that is about people and technology. So, so the web is really, we sort of stumbled across this because we're mostly computer scientists apart from Danny, who's a lawyer, computer scientist, was that society has, out of this technology, created this new ecosystem that you have to build in the micro, so you come up with some simple standards and protocols, and you have to throw it out there. And it's like the question the lady asked Bob about how did you persuade governments to adopt the internet? Well, it doesn't quite work like that. You've got to get it being used. And how did Tim persuade everybody to use the web? Well, there's a lot of persistence and obstinacy, but there was a lot of like, this is a way to do it, this is the easy way to do it, and look, they're doing it, and it grows. And then suddenly it becomes in everybody's face because everybody's doing it, and that's when it's gone viral, it's tipped over, and you can't imagine life without a Google or a Wikipedia or a well, looking at this audience, maybe you aren't on Facebook and Twitter. I don't know how many people are tweeting today. A handful, right. But anyway, in a younger audience, you'd have a lot more than that. And it's basically, it's part of the air we breathe these days. It's how we live our lives. And the key thing is, it's not just about the technology. We, the engineers, can put the technology out there, and nobody might, the people have to come and use it for something that's useful to them. It's not just like, it's not a user interface, it's not like human-computer interaction. This is, a network of machines and a network of people, us, coming together to create artifacts that didn't exist before. And it's very socio-technical. So we launched this back in 2006 at MIT. It was initially a partnership between MIT and Southampton. That's me looking very jet-lagged with Tim and Danny and Nigel and Rob Brooks, some of you will know, who was head of CSAIL at the time. And we sent this idea around. Actually, we called it Web Science. We wanted to call it psychohistory, because if you've read your Asimov, this is what we're doing. We're trying to work out what the rules are by which this type of ecosystem works, and how, therefore, you can advise people about policy and regulation and advise businesses on where they should be going to make sure it all stays for the good of humanity and doesn't start turning on us. And so, of course, that's what Harry Seldon's trying to do, sort of, in Foundations and Empire. Also, Tim wanted to call it philosophical engineering. He studied physics at Oxford, where it was natural philosophy, and he wanted to talk about this as engineers designing systems that the world's going to use, but we don't know what they're going to do with it. So we can't predict how it's going to come out. This is this micro to macro effect, and it makes it really difficult to forecast the future, to identify what are the good and bad things you're doing in order to keep things going in the right direction. We had some quotes from well-known people, and then we were off on our own, and we created the Web Science Trust. This is a slide Nigel produced around 2006-07 to show the interdisciplinarity of what we do, because it isn't just about computer scientists or engineers, it's about sociology, political science, what are the politicians doing with this, legal aspects, the business world, economics, so many things. So people who study in this type of area have to bring more than just the technology to the table. We organise conferences and so on. We have a network of laboratories around the world, and who are promoting and working in this area, and we're bringing more on all the time. Now, I want to finish with, not finish, there's two more things I want to say and then finish. I want to take a different view of this now. Again, this was inspired by Tim's thoughts, but this idea of, I have to use my hands for this, the network of computer machines and the network of people coming together to create what Tim called in his book, Weaving the Web, social machines. Now, this is a new concept, and some people say, well, I don't like the word machine. We used it because that's what Tim used here in his book, but it's this idea of something that only exists because it's my social science friends will say this is co-constituted between technology, the technology that's available, and people using that technology. There's a co-constructionism or a co-constitution thing here. And Tim says in his book, real life must be full of all kinds of social constraints, the very processes from which society arises. And that's how we live. I mean, we all sit here nicely spaced from each other. We've learned how to live as a society, and when we go down to eat dinner, we're not going to throw that food at each other or try and steal it from each other. We have learned over the millennia how to exist. We have laws, we have regulations. Most of the time, most of us keep those. Of course, there's horrible things go on, but generally that we've learned that, and we've got to learn how to do that in the digital world, except it's all happening so very, very fast. It's happening faster than we can assimilate what's going on, and now we're going to add the Internet of Things into that, which I'm going to come to. So in Tim and his book, he said, computers help if we can use them to create abstract social machines on the web, processes in which people do the creativity. We create the content, we effectively make the links, we even make the links for Google, they just manage the way that we do that. And the machines do the administration. The problem, of course, is that, 16 years after Tim wrote that, we think about when machines do the creativity too, and that's when we get into an interesting world of the driverless car and all the things that machine learning is going to bring us, because the machines may end up taking over the planet, as Stephen Hawking has talked about. That's another philosophical issue. But the examples of social machines are all the things we use effectively. These are the effective monopolies they've become. I mean, there's one place where you put your video, YouTube, which Google bought. I didn't put Flickr on here. There's one place you put your photos. Yahoo bought that. Facebook was a social machine. Whether it's still a social machine or not, I don't know, because it's very much been, it's taken over by the company more. Google is definitely still a social machine. Google needs the open web in order to function for the search engine piece. The Twitters, the Wikipedias, they're all examples of things that started as a very simple set of protocols that you could do not much with, and because of what we, society, have done with them, they've grown into these big new artifacts. Amazon's, eBay's, they're all examples that started as social machines, and they're evolving, and then as they go into the commercial forces take over, they take on a different type of structure, and that's something we're trying to learn about today. Slide from my colleague Dave DeRohr about how, in the context of, if you forget the people bit, you've just got lots of computers generate data and enable us to analyze data, and the more computer power they have, the more data you produce, and the more you can analyze it, make sense of it. You add the people in, the social networking has evolved, and the two together is where social machines fit in this context. So there's a huge amount of big data in analysing what people do on the web and that's the analytics of social media. There's a lot of computer scientists in this audience. Having recast web science as a theory and practice of social machines, I now know that I can recast computer science as the theory and practice of Turing machines, because in my world, in my head, if a Turing machine could produce these social machines, then it's not a social machine. But of course, we are moving out of the Turing machine space into another whole world where the machines might well create their own social machines. And that's sort of where, coming back to what I'm going to say at the end about the Internet of Things, and that we might not have any control over. And that's why I think we need to study them, because we need to think about, will the social machines have consciences? Will they be able to think for themselves as they get bigger and bigger without us being in the loop? And could they turn on us? So this is, I'm going to say something about the Web Observatory. And this, as I was listening to Bob talk, it was all about, wow, we could use that to do this project. So what we were thinking about, the web science community, was how do we do this? How do we do research in this area where you're trying to think about how people are using the web all over the world? So that's why we have this network of labs around the world, because we need to study what's happening from perspectives, different cultures, different languages, different regimes, different political regimes. There's a lot of people, some of it's of course locked away into company silos because it needs to be secure and there's all the privacy issues, but there's an awful lot of people doing research in this area and we don't share it. We don't link that data up. The Web Science Trust is a member of the RDA, by the way, just so I have hooked into the RDA so that, because this is really important, this whole, how do we store data sets and store them in perpetuity so we keep the data, so we can keep on analyse it. Because to me, I want to be able to store the data about what's happening in the social machine world and allow people of different disciplinary types, historians, lawyers, economists, to look back at that data in order to potentially think forward. We need the most fundamental thing of all, which is why it resonates so much with Bob's talk, is about storing that data in perpetuity so that not just the formats of that, but it's how you find that data again in the future, which is why the metadata is so important. We've been thinking about that in the context of web science, and we've been taking the ideas from how the astronomers, they gather all this data and then they share it in order to make sense of what's happening out there in the heavens. And the climate scientists too. This slide's a bit difficult to see, but basically, for the last 200 years, we've had records about weather. We now have amazing amounts of data collected about weather every day, and with more powerful computer models and networks, we can get the forecasting better for what the weather's going to be tomorrow and the next day and the next day, and gradually we're pushing those boundaries back. And on top of that, we're trying to think about whether what we are doing in the physical world is affecting these systems. Hugely complex research issues, lots of controversy about how the data is interpreted. I mean, we saw that the French meteorologist who resigned this week because he said that the data was being skewed in order to achieve political ends or particular... the only way scientists can address that is if the data is stored in such a way that we can go back and look at it, repeat the experiments, repeat the analysis. Otherwise, we're never going to get anywhere. And so we're trying to do that from the digital perspective. So our project is very much about enabling researchers around the world to share the information about what data sets they've got, what they've collected, how they've analysed it, and telling us whether how to repeat the experiment or whether we can look at the data they've collected, and to enable longitudinal research and to enable people to look back. Wouldn't it be great to be able to look back at the day Egypt turned the internet off, or when Facebook took over MySpace, and to look back in order to think forward. So that's our software telescopes looking at this system we've created. There are potentially quantum effects here, because if people know they're being observed, they will change their behaviour. So there's an awful lot of social science you have to take account of here. And of course, this, as I said at the beginning, this is one big experiment. And if you read your Hitchhiker's Guide to the Galaxy, it's all down to the white mice anyway. But I was talking to a group of lawyers last night and coming up with the idea, well, maybe, you know, if Facebook is closing everything down into its world, then maybe we'll get a campaign for a real web emerging, and we'll rebuild it and think get it better the second time round. Is that feasible? I don't know. So very quickly through these, I want to get on to some important last slides. So I'm not trying to say all data will be open. There have to be levels of access to anything that we talk about, and Bob mentioned that too. There has to be a lot of security around different types of data. If you're going to start sharing it, you're going to know who you're sharing it with and what they're going to do with it. And some of it will be deeply private and needs to be kept very secure. And the Digital Catapult in London's working on ways of, I hate to use the term safe harbour this today, but this idea of how you can put data into safe harbours so that people can do research on it without that being released into the into the wild world, whatever we call it, the real world. And the idea is that I'd like to see a map of the world covered in flags where people are saying, I'm a web observatory, just like people say, I'm a meteorologist, right? This is the data I've got about what either I've done on the internet, because we could all be our own, we can be observatories ourselves. With all the Internet of Things that's coming, we could be our own observatories if we were prepared to share our data on a global level, under some conditions rather. Or we're going to have communities of researchers where there are data sets that are stored in perpetuity, and we need to very much get into the world of the DOA and make sure we're using that properly. We're sharing the tools we use to analyse it where we can, and then we allow communities of researchers who are not the techies, not the hackers, right, to access that information. So we're sort of building a social machine to observe social machines, because until there's anything in the observatories, nobody's really interested in them. So it's all psychohistory, really. We have an observatory at Southampton, data sets, repositories. We've built one that other people can use. And we share information with our colleagues in China about different data sets and what people do with them, and we compare different types of social media to see when people first talk about things and so on. I haven't got time to go into this, and we link all the observatories up. We've got an internet science one, which is funded by the EU, which is very much more in this world about sharing information about sensors and telecoms networks, and will become an Internet of Things observatory, I hope, over time. I look to the EU funder there to think about that, because we need some more funding for that one. We just installed one in Bangalore, which is focused very much on business data, and these are just examples. There are many now going up. There's one in Korea and one in Indonesia, and the South Australia one was funded by the South Australia government to do public sector, YouGov type stuff. How do we catalogue these? At the moment, we keep it very simple. We just ask people to share the metadata with us, and this is where I can link with the DOA project, because we're just using schema.org at the moment, which comes out of the sort of linked data world, very simple, and saying, just share your metadata. Don't make it too complicated to start with. Just tell us what you've got, so that we can share that with other people. And we do that through the, at the moment, through the Web Science Trust website with the catalogue of the observatories. This is an out-of-date slide. But the key thing is that this will, whatever we're doing with this, it will change, right? It will cease to be what it is. It will evolve into something else. So we have a very simple ambition to map the digital universe, and I say that very humbly in this with the people in the audience here who have achieved such great things. So these are my final slides. I've said what next for the web, but actually this includes hugely going into the Internet of Things. Finally, you'll say, where's she going to talk about that? So the big issues in the world of the web at the moment, the net neutrality issue, internet governance, cybersecurity, the privacy trust, and re-decentralization is Tim's big theme at the moment. These are issues that are going to be still there as the Internet of Things approach. So these are going to be, I know we've got a session on security this afternoon with experts in that field, and that it gets even worse when you add the Internet of Things in. We've had the fallout from Snowden, and we have all the issues about who governs the internet. And we haven't worked that out for where we are now, let alone how we govern the world that's going to have the Internet of Things. And this is the way I think of it, like the Monty Python foot. Right, we've got our relatively comfortable we sort of understand a little bit about the Facebooks and the Twitters and the Googles, and now we're going to have the Internet of Things sort of descend on top of us. And what I'm interested in is how you now got this 3 or 4 way compact of the internet and people doing things on the internet. So there's people in here, and then you're going to have, and you've got the social media companies in that, and now you're going to have an unregulated space of millions and billions of things that can talk to each other in ways we can't imagine. Without that, I mean, the saving grace for me is that this doesn't yet have an interoperability standard. I often say, and I say the Internet of Things hasn't yet had its Vint Cerf Bob Kahn or Tim Berners-Lee moment. And what Bob talked about, maybe give it that. I mean, if the DOA gives the overall standard for linking, because it's all about data. Actually all about data, and that's where the interoperability is going to come. At the moment, I feel a bit safe because it's in silos, and we might have, because it's in commercial silos at the moment. Somebody put a slide up about that. And that sort of is a bit of protection at the moment because it's not gone viral, and so we might have a bit of time to work out how to manage it so that we use this, because it all works for the good of humanity and not for the good of the machines, right? And the W3C, I know, Vint, you just said you're going to Japan next week. W3C are talking about Web of Things, which is another way of doing the interoperability at the data layer. So the proposal there is take the data up to the standards we know already for interoperability in the web and do interoperability there. And that somehow maps onto what Bob was talking about. I'm just about finished, Hattie. We're all right. So my worry is that we're creating an environment for the growth of antisocial machines. And I just leave you with that thought to discuss. And one other, I think this is my last but one slide. One other slide after this. So yeah, that piece about, if Tim called what we're doing benignly with the web social machines, where we are doing, until the commercial forces come in, what we want, and the technology shapes itself around us, we're now putting into a world we have no control over, really. The only control we have is whether to buy the stuff or not. Right? So, and which company you're going to buy it from. So it's a different world to the way the web emerged. But that's really the message I wanted to get across today. My friend Manuel Castells, a social scientist, who was very supportive as we developed web science, he talks about power and networks. And he says we have to be aware that the power relies on the control of communication, and digitization of everything implies digital surveillance can be comprehensive, and this is unprecedented. And this will happen even more so in the Internet of Things, because everybody will know where we are, what we're doing at any time. And doesn't it worry us about who has access to that data, whether it's governments, secret services, the big companies, who is going to have... I often think of the potential for a James Bond villain of the future here, who will hold the whole world to ransom because their company has taken over the world and has all this data and knows exactly what we're doing any minute of the day. So there's this sort of dark side that we need to be aware of, and the sort of Big Brother or Brave New World, Aldous Huxley's Brave New World that we've got. And it's all about the data and who controls the data and who has access to the data. And my final point, Big Brother, is I don't know how many of you have seen the film The Martian. In this film, he says at one point, looking at, his terrible predicament, I've got to science the shit out of this. And J.P. Rangaswamy gave a great lecture in Southampton last week about web science, and he came up with this quote, which I'm now using, credited to him. In terms of big data and the Internet of Things, we're going to have to web science the shit out of this. Thank you.
I think I'm going to brave Cathy's wrath and perhaps go on for 10 minutes. Question answer. Bob, would you come up too? Just two things I'd like to say. I hope you all see the relevance of these much more embracing talks on both big data and on identifiers, data management. One point which immediately links Wendy's talk with the Internet of Things much more directly is if there's been any agreement on anything in the Internet of Things, it's that probably the data from it will go over the web, at least for all the initial purposes.
Absolutely.
Which means that irrespective of just big data, web science and the Internet of Things are very closely linked. Equally well, that identifiers are absolutely fundamental to Internet of Things is also agreed. So there's no question about the relevance there. One worry I have, though, about what you said, how safe we are, I would just remind people about programmed training on the stock exchange in even one domain, where because programs directly worked on the data with no people in between, whereas Wendy assumed you still have people somewhere around.
No, and I think that's an example of potential bad side, because things happen on the stock market because the machines have decided they're happening.
That's right.
And cause chaos in the economic markets, where you have the people on the 6 o'clock in the morning news saying, I don't know why that happened. It's because that's what the machines are doing. So that's a really good example, actually, of what I'm talking about. Thank you, Peter.
And the worry is, when this becomes there in the Internet of Things, who is legally liable for what? Absolutely. When these things start happening? And I did say one of the things we're not going to deal with is legal questions, liability and governance. That would take us far too long. Now, are there any other questions to the two on the talks? I deliberately decided to have the talks together.
That could work very well, actually.
Peter, the microphone.
Oh, I can't see.
It's down there, back there.
Okay, fine.
But it's not on. The tech is up.
Okay, I'm going to speak out loud. One item I was missing is the right to forget and how that affects the control of things.
Oh.
Obviously, it's for you.
Well,
for both of you.
In a longer talk, I would have included that. In fact, I've just written a paper. All academics say I've just written a paper about this. Literally, I have with Nigel and Kieran O'Hara about this, because it is hugely complicated. First of all, it's really technically complicated to remove data forever from every data set, and everybody that's ever linked to that data set. I look up to people who are more expert than this than I am. I think it's probably impossible. And secondly, who has the right to change history? So the big issues, we can't tackle it here, but it's a really good question. And I think, we're both working in the world here of identifiers in perpetuity. Now, if you work at that meta level, and I think this is where Google works at the moment, you can remove links. Right, so, and you could do that through something like the DOA, you could set that up, but it doesn't actually remove the data from all the different servers that it might have ended up on. You're only removing the links. But anyway, and who has the right to do that, and who should have the right to ask for that to be done.
And are they removed forever, or can someone
Exactly.
put them back again?
Exactly. Big issue at the moment.
Yes. I can't see.
I
I think you better deal with this. I can't see against the light.
I think I just got the.
This is Takashima Tsuda, Kyoto University European Centers. I have a question about the future prediction. One is about the architecture change. If the architecture, maybe 10 years time, the symmetry, a new evolution of technology is coming, then some architecture may change. So could you predict the future? How long does it take to introduce the completely new architecture, new symmetry architectures? Another thing is for predicting the near future, what kind of the technology, what kind of society is coming. This is to Wendy's. I think the prediction in the next hours, next 3 days, it's very important. But so far the machine is strong if the boundary condition is fixed. But if the boundaries we are moving or extending more and more, still the mankind prediction maybe I hope stronger. So how do you think about the machine is overwhelming the human?
Bob was question first about.
Well, I must confess, I first thought it was all in Japanese, but I had trouble understanding the actual English. So I think what I will do is either try and figure out a good question that you might have asked and answer that, or pass it over to Wendy, because I'm not.
I didn't understand the piece about you asked about the architecture.
Let me say one thing, just to get the point on record here. I think there's a real challenge in the future for all of us as we deal with these complex architectures. And the challenge is for us to essentially make it clear or provide a pathway for people who are invested in and embedded in these architectures to understand enough of what's going on to be able to relate to it. I mean, I think an automobile is a very good example. Yeah. When you buy an automobile, you are not expected to know everything about that automobile, how every part of it works, and yet there are some things that you are expected to know about it. Like if your gas tank runs out of gas, the car is not going to go. It's not like you call a mechanic when your gas tank is getting low. You drive it to a gas station and fill it up. So exactly what is it that people will know about complex information systems? Let's say just in their own home, for example. Let's say you've got 1,000 different things collecting information. They relate in certain ways. How is it that you're supposed to think about that? When things break, how are you supposed to know what they are? I mean, you're not going to go around and test 1,000 devices every day or every week or even every month. So something is going to tell you about that. Is it another system in there that's understanding everything about your house and telling you only what you need to know about it? So take this action, press this button, or go put some batteries in here or there, or whatever it is. But I think that's the real challenge for the future. How are people going to relate to what it is that they're actually having to deal with on a day-to-day basis? And what part of the responsibility is theirs, and what part of the responsibility should be an expert?
Yeah, really, I think you had some comments.
Just one word on that is absolutely right. And the Digital Catapult in London here did a survey asking people about their personal data, and 80% of the people they asked, these were just general people who use most use the internet. 80% of the people they asked didn't realise they had any personal data anywhere. It doesn't compute. They just don't. They're so unaware of how this stuff works. It's an incredibly complex system that very few people have a handle on the whole. I don't know that anyone in the world has a handle on the whole thing. One thing about predicting the future in this world, it won't be about predicting. It'll be about it's more like Harry Seldon in Foundations and Trends, which is trying to think of what we're trying to achieve and keeping that in our minds as we go forward. so that we can suggest that this is the way for a good scenario and this is the way for a bad scenario. It won't be a prediction like we know it for weather forecasting.
Okay.
Yes, I was listening to you talking about linking and also about the what you need, right, to be forgotten. I think it's going forward, if you look at things differently, rather than linking to, which is a rather passive concept in some ways. I remember when we had the early work on the digital architecture, it goes back 20 years or so, the mantra there was access to perform stated operations on a sequence of disks. So it's a lot of education procedure for the user, for the people, if they are involved as people rather than their software programs, to train them to put access controls. If they share that photo, which they may not want to have their boss see a couple of years down the line, then they have to make it available with security, access controls. So just linking, I think, no matter how lovely that is, it doesn't really get you to the point where you're actually controlling what you want to do. And I think that's one of the security aspects, even to the point of putting a photo out. It's really important going forward.
I think I totally agree with you, but I think it's far too complicated for most people. And I think the problem we have today, very quickly we've moved to a world where people just put their data out and their information out there, and they don't know, they don't care. And I think that going forward, we will need people to look after our data for us.
It's 5 minutes late.
Or teach people to look after it themselves.
I just think it's too complicated.
I think we should continue on.
Bigger job.
I should have mentioned as chairman that asked people to give their names. Patrice has actually very much been involved with the design and the legal aspects of this architecture.
Well, it's a really good point, and one to be debated.
Well, I think I daren't stretch Patty's wrath too much further, so I'd suggest that further questions should go in the interval, but we should now stop for lunch.
Thank you.
We have a young scholar presentation in the Cone Center, so if you want to grab your lunch and move down there, we'll have some interesting presentations from a couple of entrepreneurs in the IoT space, as well as an opportunity to meet some of the students who submitted their posters and abstracts, which are in your program and which you had a chance to see earlier. We'd love to see you participate in that. Thank you.
Thank you.
I found your poster, this whole
Are you trying to shorten? I've got him. It's this one, right? Yes. Okay.
See, who are we missing? Thank you for waiting patiently.
See you again. So what's the plan? You're going to speak individually and then you're going to start doing panels?
Let's see. You're it's last. So yes, okay, it's there. And so Ross, first Jane comes up. All right. So. Well, ladies and gentlemen, thank you very much for allowing us to delay the beginning of this session so that people could have a chance to see the young scholars or finish lunch. By the way, the young scholar session was absolutely smashing. Wonderful, creative ideas, great stuff. So this, and most of you should have discovered after listening to the first two sessions, that there are some issues lurking in the Internet of Things which we cannot and indeed must not escape. And this has to do with security, privacy, and I dare say we should add safety, and civil society, which is us, and our the impact on us of this rapidly evolving environment of programmable devices with bugs in them that may or may not perform the way we anticipate. And to make matters more complicated, if we may be incapable of predicting misbehavior or even understanding what has caused something not to work the way we expected it to. It could be because the device is not working the way it should, or it could be that our understanding of what that device is supposed to do is not satisfactory. And figuring out the difference between those two is sometimes a challenge, which is why I think every device of this type should have a button on it called WTF, which you push when you can't figure out what it is that's going on. Now, we have a very distinguished panel to brief us in this afternoon session. It's to be chaired by Jane Holt, who is a very dear friend now, but she was the former Deputy Secretary of Homeland Security, and before that, she was the Executive Vice President of the UN Foundation, and before that, I understand, among other things, Jane had the responsibility for managing logistics for the Blue Hat guys in the United Nations. So she figured that managing a panel of these three people shouldn't be too difficult after those experiences. If you will turn to your programs, you'll discover the brief bios for our three other panelists. First being Ross Anderson, who is up at the beginning here. There he is. Professor of Security Engineering at the Computer Laboratory and a Fellow of Churchill College, the Royal Society, and the Royal Academy of Engineering, et cetera, et cetera, et cetera. And Ross, that's all I'm going to say. If you feel the need to say more, you should do that. Next is Antonio Scarametta, And Antonio, you will find where I'm looking. Here we are. He's a full professor at the University of Murcia. Did I say that right? Yes. Where he received PhD degrees in computer science. And he's worked on a variety of projects in national and international areas of networking, security, and IoT. So, and if you feel the need to say more, you'll do that, I'm sure. And finally, Rob von Kranenberg is the author of a book called The Internet of Things, A Critique of Ambient Technology and the All-Seeing Network of RFID. Network Notebooks, O2, and Institute of Network Cultures. So I'm relying on Rob to basically rabble-rouse in the course of this panel. So let me invite Jane to come and sort of set the stage for what comes after. We're going to do the same thing we did this morning. Jane will speak for a few minutes, and then we'll have each of the panelists come up one at a time, make an introductory remarks, and then the entire panel will assemble here in order to have the battle which is to come. So Jane, you have the floor.
Thank you, Vin. Well, thank you very much. And I certainly feel, as I mentioned to Hattie, like the type 2 error in this group. But my PhD is in political science with a focus on how wars end, why they end when they do, why they don't end sooner, and how factors combine to keep wars from ending. And it's an endless supply of information, needless to say. But I moved after that into a field called conflict prevention, with the very basic insight that war is not the weather. And so why do we act like it is? And how do we understand agency and conflict? Gordon Craig, a very celebrated historian in the United States, that said, absent political context, war is abject violence and soldiers are witless mechanisms that kill. I began my career as a soldier. And despite what my friends and family might have said about me, I didn't think of myself as a witless mechanism that killed. Over the course of my career, as Vin mentioned, I found myself ultimately as the number 2 in the Department of Homeland Security, responsible for, among other things, building an architecture, a framework, or an approach to the cybersecurity of the nation's critical infrastructure, and I want to talk a little bit about that. And in the course of doing that, I asked myself a lot of questions. We asked ourselves a lot of questions in Homeland Security, like what is the role of government? You know, in 1648, the state system was formed so that citizens would have the security of their sovereigns from marauding outsiders. And for most of us in our lifetime, citizens have needed the safety and security of outsiders from marauding sovereigns. And we haven't quite figured out where it's all gone wrong. When we look, though, at the question of cybersecurity and the internet and the explosion on the Internet of Things, the first word that has to come to you is reliance. In the US marketplace, and indeed in Europe, there is no enterprise that delivers value in the marketplace without relying on IT and access to the internet. And the vulnerability is complete. In 25 years, there's not a single problem really that we've solved with respect to security. There's not a single thing that you can do confident that your identity and your information won't be subject to compromise. Well, where are the trade-offs? In the US, during the past 5 or 6 years, we've been talking a lot about the trade-off between security and privacy when it comes to getting online. Where are the incentives? Vint focuses a lot on understanding the incentive structures. We used to do that too. And where can we place expectations? So I think there are a lot of questions in all of this, and particularly with everything suddenly cyber, it can seem like a lot of blah, 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 what I used to call with my colleagues B3. You know, there is a B5, and under extreme circumstances, a B7. We've all been in those conversations. It's what my colleague Tony Sager calls the fog of more. You know, there's more information, more wand waving, and the voodoo that you do in technology and cyber is really quite distant from those of us who don't count ourselves as technologists. So for me, I've reduced the questions that are really the most perplexing and the most demanding of policy action to 3. The first question is, how do we architect systems we can trust from components we can't? If ever there were a group who could answer that question, it seems to me it would be this one. Question number 2, how do we ensure the integrity of our information and our identity in an open internet? And all of those words are important. Now, people are concerned about privacy. My husband and I have spent our entire careers, over 75 years, as he's fond of telling people. I'm not so fond of telling people that. We've spent our entire careers in the public sector. We have no secrets. But people are very, very concerned about privacy. I was the lead negotiator for the United States with the European Union on what is surely the last big data sharing agreement we will ever have between us, the PNR, the Passenger Name Record Agreement. I was the lead negotiator. And that pivoted around the question of privacy. The Europeans viewed it as a data sharing agreement that pivoted around privacy. We viewed it as a security agreement that pivoted around safety and certainty. The European view of privacy that was brought to the table was a view, essentially a property view of privacy. The owner of the information has property rights and control in that information for the life of that information. It's not the American view of privacy. The American view of privacy is all about the citizen's ability to limit government's ability to intrude into our lives. So question number 1, how do we architect systems we can trust from components we can't? Question number 2, how do we ensure the integrity of our identity and our information in an open internet? Again, this is not about privacy. To me, the key question is about integrity. My blood type is A positive. I don't care if you know it. I do care if you can change it. And I do care that our systems can't alert me and tell me to the fact that you can. And question number 3, what will the role of government be in all of this? So we know that we've got an accelerating profusion of complex boxes with ever greater complexity, although we saw a very cool toy that sort of decomplexified all of this, the Sandbox. Sam Labs, it was really cool. And there are no requirements that any of these devices come equipped with even de minimis security features. And much of the software that most of us use is shot through with vulnerabilities. And our constant demand for convenience and speed and sophisticated technology is coming to an audience. For most of us, we have neither the understanding, aptitude, vocabulary, or inclination to be part of the problem. So if we're trying to tackle the ability to architect systems we can trust from components we can't, we really are at square one. When it comes to thinking about integrity, what's the problem? Most of us want privacy online, but very few of us are talking about or even willing to talk about it, even understand the basics of integrity. And when it comes to privacy, very few of us are willing to take the basic responsibility to see that our privacy is maintained. I mean, people say to me, well, what are the rules about sharing passwords? I said, do you share your toothbrush? You know, I mean, if you don't share your toothbrush, you probably shouldn't share your password. It's really hard to find principle here. We object to governments having precisely the same information that online companies routinely collect. And so this is the question that really draws out passionate discussion about privacy. But should we really expect Sony or eBay or Home Depot in the United States to safeguard and protect your phone number when, in our case, it's been out there since Glenn Miller was playing Pennsylvania 65000? So, I mean, it's very hard to find principle here. What is the role of government in all of this? How should we understand what's happening? What is the value proposition of government? In fact, what we know is that most people don't interact with government unless they have to. What is its value proposition? For me, the value proposition of government is to deliver threshold conditions for security, well-being, and justice. But what we're discovering is that both the tools that they have, governments that is, to deliver that value proposition, and the value proposition itself is changing. What do I mean by tools? Governments have lost the corner on the market, on the control of lethality, the control of capital, and the control of rulemaking. And where that control has gone has not, I can tell you firsthand, since I'm back at the United Nations, it has not gone back to the United Nations or into the United Nations or collectives of governments. And there are no black helicopters, for anyone who is curious. Where has that power and authority gone? Well, when it comes to security, there are private militaries, private armies around the world that can outgun official forces in many, many, many places. When it comes to capital, I mean, governments have never been very good at reaching either the very poor or the very rich, and there are individual human beings that have greater wealth than the majority of countries in the United Nations. And when it comes to saying what the rules are, we're seeing here too that governments have become little more than market participants. We're in an age of a global cyber awakening. This is a tremendous, as this audience certainly knows, environment of growth. For a global population that is already healthier, wealthier, more educated, more mobile, more informed, and more active than at any time in history, it's hard to overstate the implications of this global cyber awakening. We connect instantaneously to information and each other, and the consequences are profound. In the first case, it allows us all to deminiaturize ourselves. Oh, she's the Jew. Oh, he's the Muslim. We can deminiaturize ourselves online, and it renders meaningless the notion of minority, and certainly meaningless the potential effects and judging the potential effects of a minority. We like this, and we like more of it. So what are the consequences, though, of the global cyber awakening? I think the biggest consequence is understanding that it's intersecting with a rapidly accelerating, declining trend, a near collapse of trust in public sector institutions. We don't trust any of them anymore. We don't trust banks, we don't trust business, we don't trust the markets, we don't trust the media, we don't trust governments, we don't trust iconic figures, and we're angry about it. Everywhere around the world, people are angry. And they're angry not so much that we don't trust these institutions, we don't. We're angry, it's an anxiety-based anger, it's not a purpose-driven anger. With purpose-driven anger, people will kill each other. In anxiety-based anger, it's based on the fact that we don't know how to architect trusted institutions in public space anymore. And it's true around the world. No one's got the corner on the market on this. Why aren't governments doing better here? In my view, when it comes to the internet, when it comes to life online, governments don't have the power that matters. And this is particularly visible in cybersecurity, because security is something societies assign to governments to handle. We want safe streets, governments, you run the police. We want a safe country, governments, you run the military, you make the laws. But in cyberspace, it's not the power to protect us that matters. It's the power to connect us that matters. And governments, by a long shot, don't have that power. And in fact, they are flailing around. All 193 members of the United Nations, not any two of them are approaching the problem in the same way. They perceive threats in cyberspace from outside their borders. Some perceive the greatest threats in cyberspace from inside their borders. And some aren't preoccupied with threat at all, but see an awful lot of cash changing hands and have no systematic way to get access to it. So what are we going to do? Well, we could rely on the fact that we know a lot about each other, and we're learning more every day. I think what we know about each other, though, is principally as consumers, not as citizens. That has to change, and it is changing. Secondly, we often, certainly in our societies, we rely on the rule of law. But law here is neither guide nor guardian. Law is always a lagging indicator, but it seems particularly behind the curve here. So we know that the internet is changing everything. I can think of only 2 countries and 2 institutions that can count among their active number 1 billion people or more, being China, India, being Catholic, and being Muslim. And there are at least 2 internet companies, Yahoo and Facebook, that can claim those numbers as well. And those internet companies know an awful lot more about who is affiliating with them than either those governments or those century-old institutions. We're facing challenges here, challenges in security, challenges in safety online. We worry about our privacy. We're worried about who's talking about us. Well, as we've seen this morning, it doesn't matter if you're talking about yourself or not. It doesn't matter if any of the rest of us are either. Your car is talking about you. Your toaster is talking about you. Your telephone is talking about you. And we're introducing a new economic model. Facebook has introduced a new economic model now for 10 years. It's called the friendship. Google's economic model seems to be you and me. All of this is up for grabs. We don't have any clear answers. We need to learn how to architect systems we can trust from components we can't. We need to learn how to safeguard our integrity and our information in an open internet. And for goodness sake, we need to figure out what the role of government will be in all of this. Thank you.
Wow. Thank you, Jane. So Ross is going to explain to us why it is that we should be worried about this stuff that's surrounding us. There's this stuff called malware, which doesn't mean you any good. So Ross, you've got a presentation there.
Yes.
So we're going to do a fast swap.
Yep.
I am always worried about this.
Well, HDMI should make it work a bit better than VGA.
Well, we're about to find out.
Yeah, okay.
Wait, we've got it up here. Does that help, or did you change? No, you've got it here. All
Yeah,
right.
it seems to work.
Yeah. Duh.
So we have computation.
The Internet of Bad Things.
Yes, the Internet of Bad Things, right? The Internet of Things 10 years ago was called Things That Think, and 10 years before that was called Embedded Systems. And of course, it's not the things that are bad, but the software and the actors behind the software. And every industry is about to become a bit like the software industry now that you've got CPUs and software everywhere. That means that you've got the good, the bad, and the ugly. The good is platforms in which you can innovate rapidly. The bad is malware and so on, and the ugly is monopolies. How's the world going to change? Well, things will become more like the software industry. And if we want to know what's likely to be bad about the Internet of Bad Things, look about what's wrong with software now. There, for example, Herr Winterkorn was, until a few weeks ago, the respectable CEO of Volkswagen. They got caught with bad software in their cars, and you can see on the right what happened to their share price. And that's not all. We have a big scandal in Britain with £20 billion being wasted on smart meters that are supposed to save energy. But the way the system's been set up, they can't possibly, because they're in the hands of the energy retailers whose interests are in maximizing sales volume. Right? You don't need a PhD in computer science, you just need economics 101. Safety of medical devices. Read the works of Harold Thimbleby. Unsafe medical devices kill at least as many people as motor vehicles do. That's 2,000 a year in Britain, maybe 40,000 in the USA. It's fixable, but it's a regulatory problem. It is the FDA's fault. It is the MHRA's fault. That is not anything magical. That's about finding the political will to fire some people and replace them with other people. Surveillance of drug efficacy and safety. See papers by Ben Goldacre. Same regulators, same solution. Redlining. How do you regulate AI? Nobody can possibly regulate all these wonderful algorithms that people have in their data centers. Well, we've got laws against redlining. And if your computer algorithm causes black people to be charged more for their car insurance or to be offered skanky deals on credit cards, you can go to jail. We have the laws. Why doesn't somebody enforce them? What are governments busy doing? Well, governments see this not as an opportunity to do better regulation, but to do surveillance. And we've had all sorts of news over the past few years of governments using malware to spy on people. Snooping Dragon, if you look at our tech report on what the Chinese got up to. The Bundestrojaner, the debate in Germany about whether the federal government could put malware on your PC with a warrant to keep an eye on you. Warrior Pride, Google it. Mr. Snowden, thank you for passing those papers on. So what does the Internet of Things mean? It means that now your kid's Barbie doll has got a microphone, right? It does speech recognition. The kids love it. So what happens to the speech? Well, guess what? If you do the speech recognition in the doll, the battery lasts for a day. If you take it out through your domestic Wi-Fi and take it to a data center in Oregon and do speech recognition there, then the doll's battery lasts for a month. So guess what Mr. Barbie does? And guess who's going to have access to it once it's in Oregon? You guessed it. And suppose you're the Addams family, our local North London crime gang, notorious drug lords, who deal heroin in the back of a moving taxi and don't take phones with them so that the police can't track them. Well, nowadays, if you buy a car, the car's got a built-in microphone. so that if you've got a crash and the airbags go off, you can speak to the guy in the call center. So why doesn't the Metropolitan Police get a warrant to turn on the microphone in Mr. Adams' taxi and listen to what's going on and make a tape for the guy with the nice 18th century hat? And the drug squad, if our smart metering program ever worked, which it probably won't, but if it did, then the drug squad's going to want to be able to read your meters so that they know who's running a lot of lamps. And a big debate, in fact a court case before the Investigatory Powers Tribunal, is whether the government needs one warrant or many. At present, the government's view is that a minister signs a warrant once every 6 months saying, GCHQ, go hack stuff, go play, have fun. And NGOs, including one that I'm doing some stuff for, are saying, no, you should actually have a warrant for every individual intrusion that you want to make. This is security of the Internet of Things. Court case, right now, Investigatory Powers Tribunal. It's here. Let me give you another example. If you want to know how embedded systems go, follow the money. The EMV protocol suite, Europay, MasterCard and Visa. This is the chip and pin system that was developed by various people in the late 1990s and deployed in Britain a bit over 10 years ago. And Europe and Canada followed, and America, it's coming to you real soon now. It was supposed to be all rolled out last month, but, you know, IT projects are late. And this is a fascinating story of failures and frauds that we've been following with some enthusiasm for the past decade. And since we have published a lot on this, when people become victims of fraud and don't get their money back and the banks tell them it must be your fault, they often come to us and complain. So we've got, if you like, a telescope about what's going wrong with this part of the Internet of Things. That's fraud history. The banks hoped that fraud would go down. They jiggled the rules so that if a PIN is used, the cardholder pays for any complaints. Otherwise, the merchant pays, so the bank doesn't pay for fraud anymore. Wonderful, isn't it? And that's the fraud that the bank still ended up paying for, and as you see, it went up rather than going down. And it went up in a number of ways. Card not present, fraud went online first. Then counterfeit went up because people figured out ways of using ubiquitous card payments to steal card information. So here's a demo that we did. We got some terminals that we bought off eBay, and we tried to figure out if they could be tampered with. We did this after a couple of hundred people had their cards cloned in a BP garage in Girton near Cambridge. And it turned out, after my research students had stared at this for a day or two, they figured out that if you drilled a hole just in the corner there of this compartment in the back of it, you could drop a pin onto the serial line that takes the pin from the pin pad to the card and the card data from the card to the pin pad. So you get everything that you need to make magstripe card forgeries. So we called up GCHQ and we said, these supposedly common criteria evaluated terminals, they're easy to break into. Hadn't you better remove the certification? No, said GCHQ, that's not our problem. They've not been common criteria certified. We've never seen any evaluation report from them. Oh, we said. So we phoned up Visa and we said, look, you've got on your website that these terminals are common criteria evaluated, but GCHQ says they aren't. What's going on? And Visa said, well, they're not actually certified because then we'd have had to give the evaluation reports to GCHQ, which we didn't want to for security reasons, but we did go through the proper common criteria process. That's why we call them merely common criteria evaluated. Oh, we said. So we phoned up GCHQ and we said, why don't you get this guy's website offline because they're passing off your brand? Oh no, they said, we couldn't possibly do that. Failures of certification. If you can't even certify banking terminals, what can you certify? Okay, and a few months after that, they arrested a couple of guys who found their way into the warehouse in Dubai where these terminals catch breath en route from China to Europe and put bad electronics in them, with the result that shopkeepers and bankers in both the UK and the Netherlands were taking new chip and pin terminals out of the box, installing them in their branches, and having all their customers' card and pin details SMS to Karachi. And 3 years later, the trial of these Khan brothers collapsed. The banks wouldn't offer evidence because it was too embarrassing. Voila. So here's another example of how things go wrong. In EMV, the terminal sends a random number n to the card along with the date and the amount x. And the card then computes an authentication request cryptogram, which is a message authentication code on n, d, and x. So what happens if this supposed unpredictable number is actually predictable? Well, the answer is that if I've got access to your card, I can pre-compute an authentication code for it for an arbitrary amount and, let's say, for tomorrow's date. Isn't that nice? Well, how did we think of this? Well, the reason we thought about it is a chap called Alex Gambin came to us, and he was a guy from Malta who'd gone on holiday in Mallorca, and he got 4 ATM transactions that he didn't recognize, and HSBC told him to jump in the river. And so he contacted us, and we told him what to ask the bank, and he got the logs. And there on the right are the unpredictable numbers. F124 or something, 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 F124 or something, something, something. Doesn't look very random to me, does it? It turns out, if you look at it carefully, this is a 17-bit constant followed by a 15-bit counter cycling every 3 minutes. So it's predictable. So we tested. We bought some second-hand ATMs from down the road in East London. We bought them on eBay. And we had to go to a rather dodgy warehouse in a rather scary part of town with our van to pick them up from some really wicked-looking people. You know, if you're ever making a video about terrorism, I can show you where to go to get some very, very convincing walk-on bit part actors. And we took these to pieces, and we also put some stuff in genuine bank cards, CPUs, memory, and clock, so that we could do precisely timed series of 10 balance inquiries followed by a withdrawal of £20. And we found that half of the ATMs in the UK, roughly, use counters instead of proper random number generators. So why might this be? Well, we look at the EMV specification, and it says that the unpredictable number must be tested in the following way. You draw 4 unpredictable numbers from the device under test. You check that they are all different. If they are, you're done. The programmers were merely engineering to the specification. Hey, they got a living to make. You know, what's the point messing around with AES in output feedback mode if a counter will do? Guys, get real. And then we, after we wrote a paper about this, we got a variant of it that actually turned up on the street. Remember the ease with which terminals can be tampered? Well, if you can tamper with the terminal, you can tamper with the software in it. And so guess what happened? There was a British sailor, went into a bar in Barcelona, and he spent 33 euros on a drink. And he woke up with a headache, and he found that he'd been hit with 10 transactions for 3,300 euros, which had been put through at the rate of 1 per hour, more or less precisely, over the succeeding 10 hours. And he called up Lloyds Bank, and they had dunned him of £24,000, and they said, well, it's chip and pin transaction, the system is secure, so it's your fault. So he hired a lawyer, and the lawyer came to us, and we got the logs, and we looked at them, and we managed to convince Lloyds Bank that they would not be able to convince a judge that this wasn't technical fraud, because all of the 10 transactions came from the same terminal ID, but they had been routed through different banks, and they had different terminal characteristics, and there were other indications of tampering. A clear case of malware in the terminal. Can the Internet of Things kill you? Well, let me give you an example. After this happened, I got contacted by a councillor from Bournemouth, a town in the south coast of England, who said he was trying to pull the license of a local strip club because 3 people had complained to him that they had been grotesquely overcharged for chip and pin transactions in the club. So I told this story to a reporter from the Bournemouth Echo. You can go and find it with your favourite search engine. And the following week, a further 15 people turned up at the council to complain that they had been outrageously overcharged for transactions at this particular premises. So we then tried to persuade the Dorsetshire Constabulary to go and raid the place, but they didn't want to do that because computers are too difficult, right? And the point of this story is that sooner or later this is going to be a murder, because somebody will inhale vomit while he's sitting there, lying there on a bar bench, having had Rohypnol or something put in his drink, so that he won't go to another premises and use his card again while the bad guys are running out the pre-play sequence of transactions. And then it will be too late. So how on earth do you get the police off their butts to investigate computer crime even when it's clearly crime, clearly happening on their manor, and likely to endanger life? If anybody knows an answer to that, I would actually like to know it. Let me give you another example of the sort of stuff that goes wrong. You nowadays do your banking on your phone. And there's all sorts of wonderful ways to steal people's money from their phones. It's not just your credit cards in your pocket that can be used to dun you of 20,000 quid. Most people don't think that that's the price of a nice car, but that's what you can get, or what the bank will give somebody on the basis of your cards, on the overdraft limit that you never use, the credit limit that you never use, and the unauthorized credit limits that they will let you have so that they can dun you for charges, right? This can also be a vector to impoverish you. For example, somebody can steal your PIN. Here's an example that you, by rocking the phone backwards and forwards as you put in the PIN, you can use the accelerometers in the phone to determine what the PIN is. We even found that you can steal a PIN by using the phone camera to look as the person's face rocks backwards and forwards. And the latest thing that we found is that large numbers of phones don't do factory reset properly. We bought a couple of dozen phones second-hand, and in 85% of them, we were able to recover the Google Master cookie, which meant that we could log on to your Gmail. So that wasn't Google's fault, I should say. That was the OEMs who were completely clueless at implementing the stuff around Android. So what we're doing is setting up a Cambridge Cloud Cybercrime Center to collect all the data to enable us to understand this stuff and make it available to other academics. And my conclusion is that all the bad things that we've seen on PCs over the past 30 years are now going to scale up to everything else as well. You see it in Android, you see it in payment terminals, you're going to see it in cars, you're going to see it in medical devices, you're going to see it in watches, you're going to see it just about everywhere. And as the strip club example shows, the authorities are completely, intellectually, organizationally, and in every other way, unprepared to cope with this. What, as Jane asked, are governments really for? Well, my answer is that they could make a very good start on this by exercising their traditional functions competently with respect to the world around us as it starts to change. But at present, I'm afraid I don't see any inclination or aptitude to do that.
Normally, one would say thank you. However, Ross, that's not the right response. The only response I can think of right now is merde. Antonio, I hope that you will have something useful to say. Oh yes, we have to reconstruct this.
Just build again.
Where do you want me to stick this?
I think it was, yeah.
Okay, and there it is,
yeah.
Up at the top.
Yeah. This one. Yeah.
Well, I hope you have something that will bail us out now.
Well, it's a difficult challenge now, I would say. Okay, first of all, thanks for all of you and for the invitation to be present here on this workshop. Especially, I thank Peter that we have been working several years all together. I was just, instead of saying something about me, I was just to say something about Peter. Peter was the person that introduced me to the research area in the European world, if you like. No? When I finished my PhD, someday I come to his office and we start talking, and since then we have continued working the last 20 years, maybe it has been there. No? We have participated in the first two European projects for IPv6 deployment that were the big scale projects. in competing projects, basically. Let's say every 6 my case, 6net, and indeed we are still friends since then. I was there, and now we could go to the IPv6 on the IoT6 in the IoT world now with another project was called IoT6 in that sense, where we have been working also again regarding all these issues regarding IoT and security also in that sense. So my presentation here will be a little bit different from the other side. I will try to introduce, by the way, I changed already during this morning presentation some of the slides just to try to link to some of the comments already been introduced by Bob and by others that in order to make it more consistent, I will say. No? So although I will talk later about concrete issues regarding bootstrapping and concrete security aspect regarding IoT. One of the things I want to introduce here is a little bit a motivation of some of the work we are carrying out now in order to see how things, and I call it things in general or smart objects, because here we're not talking just about sensors. Maybe we're talking about anything that can be digitally transformed and exchanged in some way. And the idea is that a little bit we have evolved, I would say, this is like evolution of the internet, if you like, now, from the initial internet was gone, then to, I would say, one center more around peoples, and what we understand is, the next wave of the internet, what's called smart objects internet in some sense. And one of the issues here is that we are discussing, and a little bit is linked to the previous presentation regarding this social webs, etc., is also about the social IoT in some sense. So the point here is, once we are in this world, basically, what is the difference between an individual, if you say a person, or an object on that scenario, in the sense that from the endpoint of the communication is an entity being able to transfer or transmit information. I don't care who is at the other side. I don't care, globally, I don't care who is at the other side of the endpoint of the communication. It's someone that's producing information. And the point is why we need to treat it differently from another kind of identity. At the end, it's an identity that maybe it is because a user is able to take a thing, get it part of his environment, if you want, and start sharing information with that things, in the sense providing you information about my location or about, as already was said, about my home, and now he's coming to at home, it's going to share some of the resources I already have in my home, and I want to allow him to use it in that way. No? So a concept here is about extending the concept of identity, and then this will link with the Rob presentation about also the need of an infrastructure to manage all this stuff. The idea of extending the identity in order to also support right delegation, for example, is I have an object, this object I want to share it with someone, I want to allow him to use during a certain period of time, and then basically what is the consequence about adding this thing to the temporary personal space of the other person in that sense. Person here just to make it more clear, concrete, and also just to link this with the social civil society in that sense. Okay, so and this is a little bit a work we start doing some years ago about the idea of that at the end. I want to talk about an entity. I don't care if it's a person, it's an object, it's a file, it's a database, etc. And the point here is I want to go to be able to create different identities. Link it, what we call partial identity or virtual identities, link it to the usage of this entity in that sense. That will depend on what is the information I want to share, with whom I want to share, and that will create different instantiation of the same object, if you like, but that will be presented to the other guys or to the rest of the world in different means, depending on some privilege, some delegation procedures I should provide, etc. So at the end, I can create different vision of the same entity during the time, either in different instances of the communication, I would say. No? Okay, so and this I was just introducing this slide this morning when we have the presentation about this social web, etc. In the idea that, and also because of being a presentation. One of the problems we face here is about, okay, when we are talking about entities, a person, for example, that want to communicate with other one, depend on this relation, this social relation, it's a friend, it's a colleague, it's a part of my family, etc., how things could be shared, in some sense, once I am able to get the information from these entities, that could be part of my sensors in my mobile phone, for example, how I will share this information to different other persons depend on these social relations. It's a friend, it's a colleague. I mean, the point here is to try to solve, and obviously, as you can see here again, as the idea of the trust, we need to create, depend on the trust, this different level of trust will create different kind of relationship, different way of sharing information in that sense. Okay, so there is a need to manage this, I would say, complexity on the relations in order to be able to really put objects, in that sense, smart objects, things, etc., as a first class object, I would say, of the internet, in the same way that any other endpoint on the communication on the internet. That's the key point, I would say, that we are trying to look for. No? Now, this is just a technical example, we're saying about a virtual identity basically is a partial view of an object that basically means that you have a collection of attributes and you will see certain attributes depend on the partial identity that you want to present or you want to share, and based on this, you will give up part of your information, and either you will define certain control rules, access control rules, for example, to these attributes, depending on this partial vision that you have of your identity. No? So the point here is to create this infrastructure that we need to do that. No? So there's a need, in that sense, to create, I would say, an infrastructure in place that allow us to this addressing issues, naming issues, discovery issues, as already was mentioned this morning, but not only just because of the issue of discovering, but also about how to manage this collection of attributes, and based on this, being able to manage different virtual identities or partial vision of these objects that you are already trying to address on the internet in that sense. So that can allow you to restrict the access to certain attributes, for example, depending on who is accessing that information, to provide either mechanisms for anonymous credential provisioning and partial identity. So, anonymous credential is an extreme case of a partial identity, where basically you are restricting most of the information you just are sharing in some sense to the others, and also the ability to allow that in this process you should also link it in some way to a mechanism to generate authorization credentials, so that you can allow that at the end, if you are exposing certain information to another entity and you want to share with him, you need to create a secure channel in order to exchange that information. So link all this infrastructure to the security channel creation, link it to all this process. No? Our idea as part of the work is we already have discussed it with Peter some time ago, and also with I was at some of the discussion we also have in some of the projects, that, for example, Handle as an infrastructure, as was presented this morning, is something that in principle is providing some of this functionality. Maybe there will be another one, but the idea is that we need to look for some kind of this infrastructure that are supporting this management of the identity and the IoT interaction in some way, just to be flexible and easily provide mechanisms to manage, I would say, this process. No? Okay, so returning again to the main concept that also we were talking about. So this is just to give you a picture about one of the points there. So anyway, when we are talking about privacy and security in the IoT world or in the smart objects, also I think there's several challenges. Part of them I already mentioned, but in general, other ones, for example, about that are linked to some of the concepts already we have been presented by a previous speaker. For example, about what is the incentives that you have in order to have data protection. One of the problems now, and I think someone raised it, is about why the user they should be aware, or what is the reason they should care more about their protection of their own data, apart from the difference between you and North America, in the way they approach the privacy stuff. But in general, the point here is that there's also an economic incentive that maybe can be created about data protection or data sharing, put it another way around. So why I would share data? Maybe I will be able to share it if I get some benefits of doing that, in some sense. I always put the example of my daughter. My daughter, is a teenager, and he was totally reluctant to me to know where she was. I asked him, okay, I would like to. She said, no. But in the moment when I give the incentive to her I will put a program. It was a test. It was not really my intention, but I put a program on your smartphone just to track you. He said, okay, if you give me more bandwidth or you give me another stuff. So the incentive there was, okay, she will not care about the privacy if she gets something about this stuff. No? So obviously it's this one case, but in any way, it's the idea, that at the end is a business behind from her point of view, in that sense. And this is real, I mean, obviously, I mentioned one of the key points now is to control, obviously, the data disclosure. So that's independently of the business. At the end, if I want to have control of the data, how I should have mechanisms to allow me to control how I disclose the data, to whom I disclose the data. I think it was Patrick, I think it was already mentioned, the idea about the access control solutions that really put in place the control over the user in order to identify how I want to share my information in that sense, no? How to put that stuff, and obviously make it in a very I would say friendly way, if you like. No? Obviously, there's a clear difficulties, I would say, to implement privacy enhancement technology, obviously. So this is something that we need to work further in order to make it much more easily from the point of view of the user. And some of the other points here also appear, and now it will be more important because of data analytics, is the issue of accountability. At the end, either if I'm sharing data, if I am allowing someone to share, what will happen with that data when it's out of my scope? It will go to a certain database, then it will be managed by a third party, and what will go from then, starting from that point. So some mechanisms to provide accountability, although technology already exists that allows you to manage this kind of stuff, the point is to put them in place and really make this solution being applied on the scenarios. And I already mentioned, obviously, the idea of data analytics is we were just commenting. In many cases, we are just thinking about, or people are thinking about the first layer or the first issue about sharing data. But now the problem is with all these data analytics techniques that are putting in connection information coming from different places or from different sources, and then based on this create and generate new knowledge, then either there's some way, some information that you in principle were not aware that you are sharing, and now you are sharing in that sense. And that's imply also another challenges that we need to think about how to solve this stuff. At the end, obviously, we have always the typical doubt, no? Is it possible to connect anything to the internet? And if not, or if yes, obviously, in that sense, how we make this it was said to make it trust and secure from the point of view of the infrastructure that we are putting together. No? So, additional point I was just want to raise also is that although this we are talking about is like a statics in the sense that it's a certain moment, it's a snapshot of the problem. When we are talking about IoT, that's why I put let's start at the beginning. Any sensor, any object at the end has a life cycle that go from the bootstrapping process. So the moment you take it from the box, you install that sensor on your environment. You need to connect with the rest of the sensor in your environment, what is called commissioning in that sense. And then starting from there, you will have an update of the configuration. Maybe something will be wrong and you need to restart again. So there's a complete cycle there, and the security should be in all the process, not only just on the what we will call the operational security, no? And we said, no, the running application, etc. But also in the process of the bootstrapping, in the commissioning, and obviously in the updated configuration, as already, for example, Ross has already presented about the impact of the software there on all these processes, etc. Okay, so from the trust, security, and privacy challenges, we said we have this requirement in general. Also taking into account that we are talking about, in many cases, about constrained devices in that sense. So we need to take into account this issue in order to implement lightweight solutions that should be secure enough, it was or at the same level of security that the system that we already have. We have the privacy stuff that we already manage in that sense. So how to manage sensitive information, access control solutions, and obviously minimal or selective disclosure of the personal information, I would say. And finally, how to manage all this in a trust environment that should go from a privacy by design to a trustworthy by design, something, and specifically in this kind of dynamic trust management environment that we are talking about, as the one I already mentioned about sharing, exchanging data, or giving data to a third party in that sense. And then we have another ones from the operational point of view that are more, I would say, standard in the sense that are affected by the issue of the kind of devices we are talking about in that sense. And specifically in the case of the management, as already was mentioned, because one of the key points here is that we're talking about not a small number of devices, but I mean that in certain scenarios, we're talking about a big amount of data that are sensors, for example, or objects that are being deployed, and the consequence of this is rather impacting in the management solutions of the key the key management configuration, etc., etc. So I want just to finalize in order just to show you, for example, this is This is a European project we are already involved. It's called Societal in that sense, where basically we are instantiating an architecture from IoT framework in that sense, where basically we have concentrated on the security part. This is the security components of that architecture, where we have extended them in order to support most of this functionality I already mentioned for access control, privacy-enabled solutions, sharing policies, for example, for group management and for creation of what we call bubble of trust in that environment, and obviously with the idea to integrate or extend, I would say, the identity management with all this needed functionality that are necessary for managing this kind of complexity in that sense. Okay, so I mean, just to finalize, I mean, this just some a small point regarding the smart city stuff, in the sense that all of this obviously is applied to the concept of the smart city, just because here we're talking about a bunch of data, not only provided by the user, but also from the institution with open data, etc., etc. So it's just, I mean, a leverage of the problems with the highest scale in that sense. Okay, and this I conclude. So at the end, I think the important thing is, as I mentioned, is that we take into account all these aspects. Hopefully will not happen like what happened in this picture in that sense. But anyway, I think the important thing is to try to make this privacy by design and get, as I already mentioned, introduce the object as a first-class, smart object as a first-class object in the internet with all the consequences that they imply. Okay, thanks.
I think what this reinforces for me personally is the importance of strong authentication, because it will be very fundamental. So Rob, you're up next, and we need to find your presentation, which is hiding in here.
It was a very nice name.
Oh, there we go. How about that?
Perfect.
So are you going to rescue us? He didn't help. Well, he helped us with a sort of an architectural design which pointed us in the direction of things we need to do. What are you going to do?
Well, I'm going to rescue us, but you're not going to like it.
Okay, I want to find, that's a challenge. I'll find out about it.
So,
Don't connect anything to anything.
well, so first of all, of course, I'm honored to be here, very much. And also, I've got a very bad cold, so I'm sort of hearing myself speaking, and so I hope I get through this, but it'll be fine. But basically, I think Internet of Things, security is a process, and as a process is distributed over objects, people, and the environment. So basically what is IoT? Is linking up the body area network, the local area network, the wide area network, and a very wide area network. So basically you link up the body, the home, the car, and the city. Google's been doing that pretty well. So Google has the glass and the lens for the body, and you go home and you sync into the power meter. Didn't really work, so buying Nest was a good idea, waking everybody up. And then I sync the data coming from my glass and my lens into my Nest, and then I go into my car, and Google's working on the car, and then sponsoring basically every open data initiative in the world, and basically lots of things happening in the library. So I think this was a logical vision, and it's also the logical vision for IoT, because if you're not able to have and host and play back to people data in all their networks, you will not be able to give them the ultimate, which is like the scenario now. So whoever ensures traceability, sustainability, security, linking up these gateways, and this is why we want the Internet of Things, giving us the best possible feedback on our health, best possible resource allocation in our homes, the best possible alignment of local and global situations for resource allocation. But I think we've been hearing a little bit about Volcano, but this is Volcano Outburst Reading. And for about 60 to 70 years, maybe even more, volcanologists try to get data out of, or information out of the middle layer, and they couldn't. So at one point there was a physicist, Bernard Chouet, and he locked himself up in his room with a lot of these readings, and he looked at the lower layer below, and there he found the information because the data was over there. So what really, really intrigued me was that for a long, long amount of time, a particular group of people were able to try to get information out of a layer of data, but basically the data was not there. So I would like to argue that these gateways, because the products are gateways, and the platform and the app are in public hands. And I'm going to do it provocatively, by proposing identity management as a kind of lever. This is basically Steve Jobs. When he came back to Apple, he closed down, first thing he did was closing down the Forward Advanced Research Group, saying research will be done in a crucible of development. And then that's where we see the iPod and the iPhone, and we saw the immense amount of massive creativity sort of focused on the here and now, building on the here and now. And he basically said, okay, we have a space of flows, and so where's the agency? It's in the device. If I have the device, I control what goes in, I control what goes out. I can even control the telcos, which he did. So basically, that's what we can also do, and I think a lot of people are thinking about this at this moment, because I think it's been said 3 times now today, we need a kind of time out. We need a kind of a little time out in which we want to look at the state of all the actors and look at the agency of all the actors in the system, and then redefine this into a new way. Because in one way, if we are now all going to book a flight to Barcelona, we're all paying a different price. And given sort of the killer app of retail, probably within 3 to 5 years, there'll not be one more single fixed pricing anywhere in the supermarkets or basically anywhere else. You go and get a meal, you get your price. You put your phone to a package of coffee, you get your price. Now, if you say I don't really buy that, then I also said that you wouldn't have really bought that 5 or 10 years ago if I would have said that we can close down the plane and then give you all, us all, specific indicators, and these indicators will then be in the hands of particular agents. We have no control over these agents. We also do not know what the real indicators are that go into the algorithms that give us our price, not your price, but my price. So these things are happening now. I think Airbnb is not going to build social housing. Uber is not going to pay for the potholes in our roads. So what we are seeing at the moment is a massive move of agency, public agency, into the hands of players that we cannot, in all certainty, hold accountable. So in such a world, security becomes a process. And as a concept, it needs to be distributed over the person, objects, and the immediate surroundings. So aiming to do security on any of these levels, but not all, is not an option. It's become a really container concept. Just in the UK, the UK business is losing 18 billion sort of every year. But the next year they spend 16 billion sort of repairing the hacks. So I would say, yeah, the sort of like the security and hackers and sort of the whole hyping of security in particular is a bit suspect. This notion of cybersecurity, I would say, is pretty much dead. So we have to take the whole situation to a new level, which is basically a pragmatic cybernetics. Now, we've been used to dealing with 3 groups of actors in our architectures: citizens and end users and industry and governance. And they all have particular sets of qualities. Now, what we're seeing, what we already saw with the net happening, what we will see more with Internet of Things, is more new entities, and these entities will consist of qualities taken from each of these 3 groups. It's very difficult to predict which is going to happen. At the moment, we see a lot of these things happening in blockchain and in banking, and there's something called DNARS coming up, which is promised to be sort of revolutionary there. We see these indicators and agents building social identities on our indicators, giving us prices, now still in relatively closed environments like the plane, but with NFC, RFID, QR codes and barcodes, we're rapidly closing down that whole system. So these new entities, they are building, and they should build, the governance for new types of decision-making structures. So I propose kind of pragmatic clean slate. At the outer ends, we have the top ability to rethink the passport as a device in Europe on the back of the Estonian e-card. Already 70 to 80% of all services in Estonia are running off this card. It's already now a service, so you can have the card as a service. You don't have to be living in Estonia. I'm project lead for DINE.org, DAOs. We're building a router, a kind of alternative router, which will give you access to the network layer, so you can actually see what goes in and what goes out of your house. We have a few of them running. They're running faster than the current routers, and they're also giving better Wi-Fi spread. We're building them on Raspberry Pis, and as the price of these are going down, looks like we'll be able to come out with a few of them within a few months. Now, within these layers, we have the notion of this multimodal security, because in the Internet of Things, there's so many contextual evidence that I'm here, that you're there, that we're there, that thinking about item-level security or thinking about system-level security is not really where things are going to happen. It's going to happen in the middle. And in the middle, there is this multimodal notion of, for example, identifying users on gait recognition, daily patterns based on their devices. So I think these are sort of the three things that are sort of happening. Now, do we want them? Well, maybe we don't really want them. But are they going to happen? Yes. I think they're going to happen. Because on the one hand, it's clear that too many value, also value which will be added value because new services based on top of that value will be played back, is moving away out of public hands that we as European citizens paid up with our taxes. And it's not just us, it's the whole BRIC, and it's of course also China. In this development plan, we hear that under the policy guidance and financial support from national and local government, fully use of the resource of industry parks, enterprises, research institutes, etc., and also other resources, establish a resource shareable complementary public service platform. I've been advising IoT China for the past, in Shanghai for the past 5 years. I can of course not vouch for sort of the fact that this would be a reality or this would be true, but there's a lot of contextual evidence, and especially with the fact that the last Chinese government had 9 out of top politicians engineers, is already basically running the country like a platform. So this means that these notions of cybernetics or pragmatic cybernetics are going to be key. Of course, the problem that we have today is that our politicians, sometimes we don't even take it's a bit of worry to talk to them because we lose so much time trying to explain sort of what's going on. But somehow we're going to have to try, because underneath the notion of that there's still some kind of democratic decision making, which is no longer really the case. We may be losing an enormous amount of public agency, and I think that if you want to build a smart society, let's say talk about Europe, then it needs to be for 500 million people. It needs to be a smart Europe. It doesn't need to be a Europe with a few smart gated communities. Now, if you want to build a smart Europe, you want to build a smart environment for everybody, you may have to resort to certain technical solutions that you may not want, but that may be the only option that you at one point have. So here's our best, one of the best Dutch artists, Sebastian Ader. We lost him at sea. He left Holland about 20 years ago in a little boat, and it was a big brass band playing. And the idea was that he would sail to the America, and that there would be a brass band there, sort of welcoming him. But we lost him at sea. So maybe he's in an island somewhere with friends, but probably not. Probably his boat didn't really make it. But it's a beautiful movie, and this is a still clip from that movie, where we see him on his bike, and he's on his bike, and he's crossing the bridge, and then, as any normal person would either go straight or fall, he drives straight into the canal. And with this, he creates a kind of third moment. He creates a kind of option that wasn't there before. So because we go straight or we fall, but we don't drive straight into that water. But he did. So I think we have a fantastic global interoperability. We have particular needs for localization. Let's try to find a third way. Thank you.
Yes, have a seat. So we'll bring the panel up now, and I'll let Jane manage. We're actually kind of over time, although we started late, so we're doing the best we can to keep us not too far off schedule. we may have to go straight into audience Q&A, I think.
I think we will.
To make sure we get, if the audience has no questions, then I'm sure the panel will go into battle mode.
That's right.
So
Everything
Jane,
is
I'll turn this over to you.
Thanks, Vince. Everything was so tightly woven, there may be no questions. But why don't we begin with questions from the audience? Yes, please.
I have a really simple question.
Please stand up and identify yourself.
I have one. Can you hear me?
No. Press the top.
No, definitely. Can you hear me now? Again? Yes.
This is one of those internet of
Yeah. Why don't you shout?
Shout.
Claim to be super, I'm an independent contractor, and my question is simple. Is trust a worthy objective, given all the challenges?
Who would, let's sort of determine an order about who would like to jump in on this? Yeah? Anyone
Sure.
else? Okay.
Trust is bad. It's not good, it's bad. Because from the point of view of a policymaker or an advertising copywriter, trust's a warm, fuzzy feeling. You trust your doctor because he's an old guy with a grey beard and there's a thing on the wall, right? But trust as an engineering concept is that somebody I trust is somebody who can break my security policy. The doctor can break my security policy because he can leak my medical records to the front page of The Guardian. So you should not talk about maximizing trust in systems, you should talk about minimizing trust. You should talk about minimizing the size of the trusted computer base. That's something geeks understand, but policy people don't.
So from a policy point of view, this is a very clear illustration of the challenges we have with vocabulary. I had a fascinating conversation on the word threat. And I think, of course, thinking of Batu Khan and the Golden Horde, and they were thinking of exploits. Trust is essential in a policy environment. I mean, we have this social contract. Societies have a conversation with themselves through their governments in a way. And what's trust in a policy environment? Trust is a value proposition reliably delivered. And so trust is not only bad, it's essential for the cohesion, not only of homogeneous societies, but more importantly for heterogeneous societies.
I mean, I think that trust is the problem is that here you can see two different visions of trust. Trust is a really controversial word, if you like. That's why I mean, at least in my case, I always try to talk about trustworthy in something. No, and at the end, it's just I would say that this equilibrium between privacy and security. I said, how you manage both stuff at the same time, so that you, as a user, in some sense, or as a designer of a system, are able to make them compatible in some way. It's not always easy to make them be compatible in some sense, because obviously you launch for one side and then you're getting the other one out there. So, but I don't think that. I mean, I think as Ross is saying in more than controversial way, maybe not. I mean, maybe you really think that trust is a bad thing. But I think it's something that at least you need. At the end, you need to have some kind of understanding of what is going to happen with your system at the end. And that is part also of how it's going to be work from the security point of view. That's the point.
Yeah, I think, well, in the break, I had a short discussion with Bob Kahn, and he was saying that one of the persons that also was in the story, that sort of is a person called John Taylor. And he was important because, if I say, he had the trust, he said, of all the different parties and sort of fractions of, he could talk to policymakers, he could talk to politicians, he could talk to the post office people, he could talk to the trade union people, sort of. So he was a kind of person that had the trust between, that's really necessary when we look, what we need is some kind of regime change, if you want to sort of like that. It's very serious. If we don't do it, we're going to lose basically the source of our value, or let's say that it will be redistributed in such a way that not everybody has agency, and it's not at the moment sort of like a full transparent situation of who actually holds the identities on which all of us will be, to which we will be measured, and it's already happening as we speak. So, as we heard also, that the role of governments is getting really, really really, really troublesome in that sense, then we need some kind of stakeholder coordination between people who understand this in the system. And I would say these are the people who work at the passport office or at banks or sort of and certain civil servants, and of course also a lot of the military. I was in a meeting 2 years ago in Rome, invited by the intelligence agency and also by the US State Department. It was talking about Internet of Things. It was like 150 intelligence professionals in the room. And when they came back, they had 5 major threats that they saw. 2 were do-it-yourself bio, which groups are being monitored very substantially. 1 was only military, but the other 2, and this came from these 150 intelligence professionals, was the total breakdown of society because of the inability of the state to deal with the digital. This was 2 years ago, and this was an assessment I myself had made on the basis of simple thinking 10 years ago, sort of basically coming from like literature, sort of looking at things but I was very shocked basically to hear that this was the assessment of the intelligence professionals who realized in Internet of Things they can no longer do item level security. I can have a lily pad running in my t-shirt now. So what do you want to do? Strip everybody of their t-shirts. But they can also no longer safeguard this entire model called the state. So I would say there's a group of people everywhere in the world that sort of, let's say 50% wants to stay and go down, and the other 50 wants to open up negotiations with people who get it. And the people who get it are, of course, also a lot of hacker groups and a lot of people that are coding, and sort of we need to have new ways of opening up communications with a lot of people who understand the nature of what's going on, and then together build a new type of cybernetics. That's, I think,
Rob's answer may be precisely the reason why the national security establishment should not be our first port of call when trying to figure out security for our life online. The intelligence community has nearly zero interaction with people on an everyday basis. When you think about the national security types of which the intelligence community, the military, foreign policy establishments, those are centralized, strategic, and top-driven enterprises. At least in Homeland Security, we were very transactional, decentralized, and bottom-driven. Now, it's not a culture of military intelligence, it's a culture of law enforcement and domestic political environment. We need new models, I absolutely agree. We probably only have time, though, for one more question in the back of the room. Can you identify yourself, please? Or not?
Vlado Handziski from the Technical University of Berlin. So I'm a strong believer that if the technology is source of the problem, technology can be at least part of the solution. So maybe to Ross or to Rob just mentioned that in passing. Do you think that the blockchain here can play an interesting role in at least winning back some of this? Yeah.
It's happening as we speak. I think there's lots of things going on in the financial sector and the banking sector. They're losing certain amounts of business that was basically also going, for example, with the fact that large companies are now putting up. So if you get your coffee for Starbucks, Starbucks is already identifying you on the basis of your pattern, and 90% of all the transactions are not being authenticated, but they sort of like going through there. So we have this, it's already what Jay said, we have this huge amount of things going on, and it's not good for nobody that there is no sense of order or agency in there. With that has a timeline, not just looking at now, but also looking at 20 years from now or 30 years from now.
Right. So, I tend to think that the Bitcoin blockchain is a bubble that burst about a year and a half ago when you had peak research and also peak value of the product itself. It's likely to tank in a year and a bit's time when the number of dollars that you get per hash that you find halves, because you'll no longer be able to pay the energy costs. And where we're working with practical stuff, like looking for ways to build better mobile purses in the third world for use with phone systems, we're using perfectly standard old-fashioned technology, but just coming up with new variants on the same theme and engineering it better. So blockchain, nope, not going to bet on that. Sorry.
Time for one last question. Yes, over here on the side.
My name is Paulina Nagel, I'm from UCL. You really, it was very convincing what you say, but what can we do? Is it actually possible to do anything to make more secure communication worldwide? What can one do?
Well, secure communications worldwide are easy if you trust Telegram.org, use their product. There are lots of people who offer secure messaging systems. My point is that that isn't the problem. The things that go wrong with Internet of Things have to do with monopolies, they have to do with fraud, they have to do with malware, they have to do with bad actors capturing regulators, they have to do with large powerful companies putting evil software deliberately into their products and the assumption that they're above the law. There are all these standard wickednesses of human societies that have been around since before the Bible was written, right? There's nothing particularly new under the sun. It's just that our policymakers and our policy enforcers think that they can have some kind of holiday, that they can take a break and they can say, well, crime is falling, aren't we wonderful? Actually, guys, it's just going online. And they decided to jimmy the figures so they wouldn't have to count the online stuff, so that they can bank the apparent drop in crime and award themselves all knighthoods. But this is just crap governance, right? What one has to do is hold the minister's feet to the fire.
This is very convincing, but what realistically can they do? Is there something that they can realistically do if they wanted to put money behind it?
Well, for example, the two safety problems that I talked about on about the second slide could be fixed if the Medicines and Healthcare Regulatory Authority had a board of directors that did not consist of retired chief scientists from drug companies, but instead had people on it like Ben Goldacre and Harold Thimbleby. I in fact went and spoke to the civil servant whose job was telling the minister which people to put forward for non-executive director posts, and he was absolutely appalled at the suggestion. He said ministers would never have it, the drug companies would make too much trouble. That's what's wrong. It's old-fashioned, broken politics that we've always had in London, that you've always had in DC, that you've always had everywhere else. The fix for it is transparency, the fix for it is lobbying, the fix for it is throwing the bums out at the next election. That's how you fix it.
Well, that is traditionally how democracy works. One initiative I can tell you about... Well, one initiative I can tell you about is that my organization, the Center for Internet Security, along with the DA's Office of New York, Cy Vance Jr., and London City Police, have launched a $50 million 5-year initiative in a public-private, member-owned, not-for-profit platform to identify and prioritize some of the challenges that we're facing and taking them on. I mean, we talk about eradicating hunger, and we're not kidding anybody. We can do better in this field, certainly. Anything else from the audience? It's time, I'm afraid. Thank you so much. Please join me in thanking our panelists. We should give you more information about this initiative.
Taking a break, yes.
Yes.
That was fun.
To 5 o'clock, as according to my my notes here. So we're getting started about 15 minutes late, and we left about 20 minutes for a Q&A. So depending on, I'm not going to try and abridge the speakers, but if we have time for Q&A, we'll do it. If we don't, there is some award ceremony, I believe, this evening. And so we'll probably want to quit pretty close to on time so people can get back to their hotels and change. So I'd like to welcome you all back. We have 3 speakers I'm looking forward to hearing from at this session. I'm not going to give a very long introduction because I think their talks will speak for themselves. But we have Chris Greer from NIST on the agenda. I'll get to them in due course. So let me introduce the first one on the panel. Chris is from NIST, and I've known him for quite a while. He is a very innovative fellow in many ways. He's going to be followed by June Marai and then Luis Gomez. So Chris, I understand you're going to talk a little about NIST and some of the deployment work that you're doing there. So it's all yours. And it may be easier to just, why don't you sit down afterwards, and if we have time, we'll do the Q&A.
Okay, very good. Thank you, Bob. And good afternoon, everyone. I'm Chris Greer. I'm from the National Institute of Standards and Technology. We're a part of the Department of Commerce in the United States. We're a relatively small agency, and we're a research organization, mainly scientists and engineers, working to use measurement science to promote innovation, entrepreneurship, and in the end, to improve the quality of life. We have a number of research priorities which are outlined here, and I'm really going to focus on the cyber-physical systems aspect of our priorities today. And so a key question then is, what is a cyber-physical system? We're a measurement organization, and so we want to know what the dimensions are and how you would measure it. So really, for our purposes, there are 3 dimensions, and these are and statements. First, that these are hybrid systems of cyber and engineered physical elements. Second, that they be co-engineered or co-designed rather than IT systems added to an engineer system. These were intentionally co-designed. And most importantly, that they are adaptive and predictive in real time to enhance performance. And this has a number of really important predictions, which I don't have time to go into, but that's, I think, the key for us. Then another important question is, what's the relationship then between this concept of cyber-physical systems and the Internet of Things and the kinds of concepts that we've been talking about today? So a very simple block diagram here of the landscape of cyber-physical systems. Internet of Things concepts, Internet of Things itself is not well defined, and so we don't have dimensions yet to measure. Nonetheless, the focus typically is on devices not conventionally connected to the Internet, and of connecting devices to devices as opposed to people or organizations to organizations. So in that, using that as a reference, the Internet of Things landscape is a subset of the cyber-physical systems landscape. There are other phrases that are used in this realm, like industrial internet, and that focuses on connecting industrial systems to one another, either through conventional control mechanisms, enterprise IT and conventional networking, or through Internet of Things concepts using unconventional mechanisms. The same sort of thing can be applied to smart grid or to intelligent transportation and so on. But we think one area that most broadly covers the CPS landscape is that of smart cities, and I'll talk about that more in just a moment. So now you can see how we think about the relationship between these various definitive phrases. Another important dimension of cyber-physical systems would be scalability. And so on this slide, the vertical axis is in terms of scale, with discrete cyber-physical systems at the bottom, moving upward to systems of systems and meta systems of systems. So what do I mean by that? Well, here are some explicit Examples in the energy sector: a smart meter is a discrete cyber-physical system, a number of meters on a feeder line interacting with a smart substation, and from there to local, regional, and continental grid systems at the meta scale. Same thing applies, of course, in communication: smartphone connected to a cell with a holdback to a local, regional, and global communications networks. And so this is another example: transportation, a smart vehicle, smart intersection, regional transportation mode. So this concept of scalability, each of these is a cyber-physical system operating at different scale. This diagram, though, also illustrates the problem, and that is that Internet of Things is being reinvented in every one of these verticals. The Internet of Things solutions being invented in smart grid and in energy are not designed to interact with the transportation network, or for that matter, with the communications system. And so the biggest risk that we face in terms of economic growth is the potential that all of these develop and operate in isolation. And so an important factor then is to identify forces for convergence. So this landscape is inherently divergent. And so what are the forces we might create to promote convergence of Internet of Things across these silos? And so there are three that we're working on: an intellectual framework, a shared experimental infrastructure, and high-value horizontal deployments at scale. I'm not going to have time to share with you our ideas on the experimental infrastructure. Suffice it to say, this infrastructure gives an opportunity for people in each of the domains to work directly with one another on a common framework. That's the goal. But I'm going to touch only on the first and last. Let's start with an intellectual framework for IoT convergence. To create that, we launched a little over a year ago a public working group on cyber-physical systems, divided into 5 subgroups with leads from NIST, from academia and industry, and they've done an amazing job in defining this landscape. We've had over time about 500, a little over 500 people who have participated in this activity from the US and from around the world in industry, academia, and government. So this has been very much a consensus process. This diagram sort of illustrates the steps that they went through, starting on the left from the fact that the folks participating here were domain stakeholders in energy and transportation and communications and in healthcare. And what we did is gather from all of them, what are their concerns with respect to a cyber-physical system. So that gave us a raw list. And in analyzing that list, it became apparent that in this dotted box, there's a common framework that consists of 3 perspectives, if you will, what are called facets here. Conceptualization, what a system should do, right? Realization, how you make the system, and assurance, how you prove that the system does what it's supposed to do and doesn't do what it's not supposed to do. So those are 3 facets there. In those facets, for each facet, there are 9 dimensions, and those are aspects and concerns. More about that in a minute, but the application of this facets and aspects process is intended to give rise to an assured cyber-physical system. And so here's another way of looking at that same concepts with the facets in columns, the aspects or dimensions in rows. And so the process of developing an assured cyber-physical system is, for each of these perspectives, carry out a set of activities to produce the corresponding artifacts. So in conceptualization, this is the business of putting together a set of appropriate use cases or sets of requirements or specifications. And these activities then, give rise to a model of a cyber-physical system. Similar set of activities and artifacts for realization and for assurance. And so just to summarize how a design process might take place for a complex cyber-physical system, you might choose an agile development process where you focus first on the conceptualization phase and those things that are most critical to you in terms of this particular cyber-physical system. Understand the implementation issues, the assurance issues, and then cover the remainder of the dimensions, making the trade-offs. These are not independent dimensions, they're dependent dimensions which interact with one another. And so there are trade-offs that have to be made, and each, after going through the cycle once, you might iterate that in an agile process. And the notion is that while this is a first start at this, we're looking for a comprehensive process that covers all of the dimensions. We think we're pretty close to that. That would allow you to do the reliable design, to do reverse engineering of a legacy system you proposed to modify, to design a procurement for a cyber-physical system, or maybe even to design a curriculum for engineers in cyber-physical systems as well. And so the first round, the first draft of that was put out for public comments a few weeks ago. You can find it on the Public Working Group website. We'd be delighted in hearing your thoughts on this framework. So this gives a bit of an idea on what we're trying to accomplish in establishing a common intellectual framework that gives us a language we can speak, whether we're working in transportation or energy or what have you. But there will need to be important economic drivers to enable this convergence. And so what we needed was an example of a high-value horizontal deployment at scale to demonstrate the value of achieving convergence here. And so let me come back to this scale diagram earlier. An interesting thing that is emerging from this is, for example, with respect to smart meters, the city of Santa Clara, California, working with Silicon Valley Power, when they deployed smart meters, opened the wireless port on those meters. They were using other communications channels, so didn't need it. And so the net result is that anyone anywhere in the city of Santa Clara can achieve wireless access through the smart meters deployed throughout a city. So this isn't an energy device anymore. This is a communications device, right? This bus in the lower, it's an electric bus in the lower right-hand corner. And a group of these buses at a recharging station, right, is not just a load, it's actually a source, right? These batteries have a lot of energy. And so as a source for resilience, for quality power, reliability, this is an energy source. And this bus and its colleagues at the recharging station are not transportation devices at all. They're energy devices. And so this is an example of compositionality, being able to use a device for purposes other than those for which it was originally intended. And so one of the ways in which compositionality is maximized in this arena is in the area of smart cities. The smart city goal is all about social benefit, right? Not about the technologies, it's about the benefit. And so an example would be resilience of a city to natural disasters, right? And so if I want my city to be resilient to natural disasters, what I need is to be able to manage coordinately at a difficult moment, right, my emergency response, my communications, energy, transportation, food supply, water supply, a wide variety of other infrastructures, right? So that goal inherently draws together all of these infrastructures. Same thing for sustainable environment, a safe city, you name your goal. The net effect is to integrate infrastructures. And so this provides an example of a technology, a goal centered around technologies that draws together the verticals into a single interoperable system, provides that example at scale and requires interoperability, but it has these economic drivers. A couple of years ago, IDC estimated that 15% of cities worldwide have a smart city project. I think that's now a vast underestimate. I haven't found any cities that say we have no smart goals. Maybe there are some out there, but not obvious. It's a rapidly growing market, above $1 trillion in the projections, and generating significant economic value on an annualized basis. And so this provides sort of the economic driver for convergence. For that reason, we focused on smart cities to promote convergence as well. Now, there's a problem in this smart city market, however, and that is, to date, most smart city solutions are one by one custom installations, right? That can only be used in that one city, perhaps only by one vendor. They're not extensible, they're not scalable, they lack all of the things that I talked about with respect to cyber-physical systems. All right, so we think this is a good driver. How are we going to overcome this, what amounts to market failure? To do that, we launched something called the Global City Teams Challenge, right? This we launched last year, September 2014, the first round of the Global City Teams Challenge. And the concept is simple, and that is, what we do is promote communities working together. So we put together teams of communities who have a common goal. Let's say a team around disaster resilience, and another team around green, sustainable environment. All right, and so the cities are in the lead in describing what their goals are, identify a team with a shared goal and what it is they're trying to accomplish. Given that team, we try to identify teams of technology innovators, companies, universities, and others who have interoperable technologies that they think can help meet those goals. Put those two together in an action cluster designed to develop a city-scale deployment. That's the Global Cities concept. So we ran that one round. It culminated in June of this year. These are some pictures from the expo that was held at the National Building Museum in Washington, D.C. And we're especially proud in this upper right-hand corner, a visit by the King and Queen of the Netherlands to the site, which I enjoyed terrifically. It was a wonderful experience. But we had over 1,500 people who attended this event. There were 65 teams that participated, more than 4 cities from around the world, more than 240 companies and universities who participated in those 65 teams. And these are examples of the participating cities. And on the left from the US, the usual suspects, the big cities like New York, San Francisco, Washington, D.C., but small cities, Chattanooga, Greenville, Ammon, Idaho, Montgomery County, Maryland. And it wasn't just a US event. The Netherlands, Spain, Italy, Israel, Indonesia, all participating as well. And I think this illustrates the notion that cities are very open to working together in pursuing their goals. And all they need is the opportunity in which to do that. Here are a few examples, and I'm not going to be able to go into detail on any of these. This is from Montgomery County, Maryland, called the Safe Community Alerting Network or SCALE. This is really just the deployment of wireless access points, aggregation points, and backhaul capability throughout the county, enabling the deployment of sensors of all types anywhere in the county. It was first focused on senior living facilities to enable aging in place. That was the real goal. But because it was designed as a platform for any kind of sensor, it's now being used for government services, for first responders, for citizen engagement, whole range of things, because they took a basic interoperable platform approach. The one-time investment is going to be used dozens of times by Montgomery County. And I should add, here at the bottom is a list of partners in that. There are 18 partners in this small Montgomery County effort, and that's creating interoperability. This is from Portland, Oregon, a partnership with Portland State, a number of companies including Intel and others. And this is about a platform approach to fuse what's being done in public transit to improving air quality in the environment by using smart bus routes, agile routing, just-in-time service, things like that to promote better air quality as well. This one is Aribo. The partners here shown on the right include federal agencies like Transportation, EPA, and Department of Energy, Department of Defense, and others. These are self-driving vehicles. They had a goal of 9 deployments. They're currently well over 20 deployments in cities across the U.S. And in Europe as well. And this one is my absolute favorite. This was a high school project with participation from high schools across the U.S. And students built sensors that they deployed in their schools and then posted the data to a common database that they could all access for their own research uses. And so the students at one school could access data being generated at any school. Quickly, what they discovered was, what came out of the database was things like 8, 7, 15, 25, 32. I wonder what those numbers actually mean. And so they discovered themselves, for somebody in the standards world, the value of standards, right, and of having a common data model. So it was a terrific learning experience in my estimation. And so we'll run another round of the global cities starting next month. And this round will focus on international teams of cities and on delivering measurable benefit to the residents of the communities. Measurable meaning, for example, 15% reduction in commute time or 20% reduction in energy costs for an average resident. Those kinds of benefits that a resident will say, that made a difference to me, and it was worth the investment. We'll run phase 1 is team building, phase 2 is actual deployments and measurement of performance against those performance indicators. We already have very good participation even before the launch, a number of companies and nonprofits, but also partnerships across governments. And already formally signed on are the governments of the Netherlands and of South Korea, who will be participating with us in this project. Okay, so overall then, I think the challenge we face is to create forces for convergence. I think a common intellectual framework, a shared infrastructure for investigation, and also the ability to work together on common smart city goals will help to converge that. Thank you for your time.
Thank you, Chris. I didn't realize we were retrofitting fire hydrants. Very interesting. Our next speaker is Jun Murai, who comes to us from Japan. And much as Peter is widely recognized for his contributions to bringing the internet to Europe, Jun has done similar things in his home country of Japan. He is going to talk to us today about the IoT more broadly in Japan and perhaps talk about some significant deployments that they're either contemplating or actually doing. So,
okay.
About 20 minutes or so.
Yep. Okay. Thank you, Bob. I'm gonna talk about basically from the point of view of a deployment of the IoT and other technology, related technology, mainly in Japan, but not necessarily in Japan. Let me start. Okay, so this is something like a conclusion now that, what I think is going to be, key actions for the deployment of the IoT, which is basically the architecture, sophisticated architecture is going to be necessary. And those existing internet and the web architecture, creating the harmony with the existing one, that's another issue. The technical standards, it's for the open kind of deployment is going to be necessary. And also the very important part is vertical deployment and then a horizontal open platform. So the agriculture, medical, and those areas going to be very much getting the benefit of IoT. But the very important thing is that we do have a open platform, so that very similar to the quiz discussion about the silo and the vertical, horizontal type of thing. So open platform is necessary. And the trust and security, of course, the key issue. But when we are talking about the security, then it's talking about the risk, but also it's always a balance of the benefit and the risk. So that balance is really the important thing. Okay, so where to start with the IoT discussion is basically we are assuming that the internet is there. So everybody participating on the internet, and then each of the devices tend to be starting with the RFID and other things, proprietary communication and other things. But now it's a kind of full spec of the TCP/IP loaded computers can be a thing, and including the smartphone and everything. So, and also the processing of the huge data generated from the things can be processed with various sophisticated way with parallel computing on the internet thing. So, and then any services can be created on the internet and the web architecture, I believe. That's basically what we are viewing today. So looking back, I visited the Stanford University in the early 80s, and then I was amazed that they are working on a philosophy class with the computers and putting all the text and then analyzing the work. But then also the artificial intelligence on the first phase was analyzing the language. And I remember that everybody was talking about the language being English, but my language was Japanese, so a little bit different that time. So language dependency is still going on with the web. Web pages are analyzed after the web ages, but it's still on English, Japanese, Chinese, different languages are doing a little bit different thing. But the images analysis happened on the various search engines and other things. So now this is getting a little bit different from the language context to the image context, and then IoT. IoT is a data. So it's really more toward a neutral object to analyze and then understand. So this is basically another aspect from a technology point of view to talk about the IoT. So T is a thing, but we in Japan and our research group started with finding out the first drop of the rain and how we can find it, and then it's on the top of your head, and then there is a rain. And the second person said, oh, yes, it's a rain, and then identifying. But what we wanted to do was the first drop of rain, it's going to be a front glass of the automobile, and then the driver started to move the wiper, and then collecting all those location, and so human driver being a sensor, that was what we wanted to achieve. And then from middle of the 90s, and we successfully deployed as a test in Nagoya city for the modern 1500 taxi cab equipped with a GPS and packet network, which was very expensive by that time. And then we started to work on the internet car. So that was the concept that any rain and the speed, car navigation, traffic, and so many weather authority of Japan hated us. Police hated us because it's generated with a kind of bottom-up manner of all the data should have been considered as a kind of a government authority, but it was actually generated from people. So that was the concept. But finally, that time, well, we did the standardization among the automobile, even among Nissan, Toyota, Honda. Then we worked together, and then we set up the format. It's very difficult to repeat that effort again. But then it was deployed, actually, secretly, like a submarine. And then all the companies collected all those information from the automobile, all the hundreds of sensors with the location thing. Now, when the earthquake happened in 2011, then the people wanted to understand immediately that which bridge was broken, which bridge was not broken, for the safety of all the people suffered from a tsunami area. And then one of the person in the Honda decided by person that he's going to disclose all the Honda information without the consideration of the privacy or anything, because to save people's life. So then other companies, all the companies followed. So there was 5 information from the 5 vendors merged together because of the standardization effort before. So it was concatenated for the security, to rescue of those people. So that was one of the important point, the balance of the benefit and then the risk. This is 2 days ago, October 17th, newspaper said every single Toyota is going to be connected in those 2 countries. I don't know why. But anyway, so this technology is going to be used, and then other thing is 3D printer. I would like to talk about 3D printer. My university opened up a 3D printer for everybody, and it is connected. And then this is one of the brain science class, and then the professor said, scan your brain and bring them. And so everybody is on the first class, and then having its own brain printed, and then looking at the brains each other, and you are smaller than mine, type of thing. But anyway, so look at this site on the page. It said download this thing's button. So you push the button and you print it, and then this thing can be printed. This is a stupid things, like 3 lines of letters together. But since it's open and it's shared, so it's very much a social network of the shared things. So immediately after the uploading the idea, then everybody in the world started to print. And then since this is a software, so it can modify it easily. So one of the German musicians created this one instead of 3. So now it's a kind of shared object thing. And I talked with the CEO of Yamaha Music Instruments, Nakata-san, that why don't you open all the data about your music instrument on the internet? If that is done, then everybody can print the Yamaha music instrument. How do you like it? And he said, no, then nobody is buying a Yamaha music instrument. I said, if everybody's played a music instrument, then eventually they're going to buy Yamaha music instrument. And he said, then he was convinced, but unfortunately we drank a lot of bottle of sake, so maybe he didn't remember it. But the point is that the delivery is not necessary, no customs and no tax and everything. So this is a kind of changing the way of things to be delivered. So this is also the impact that we are working. This is a 7 years research project we are having. So, and let me see how much time I left, but I wanna. This is one of my students working on a leg creation thing, and the leg is in a very big, large factory. They are creating it, and then different materials, and then the patterns of the legs is like the single patterns, different size, but it's not really the shape of the other legs. So what we are doing is scanning the remaining leg and reversing it and creating it by the 3D printer. So which can moving this factory with just a 3D printer and software. So this can be carried to everywhere in the world with a very inexpensive way to support the various people. So the different filament and then the 3D printer is not that expensive equipment, just the size. So we do have a large size and then delivering it to the everywhere in the world. That's the purpose of the very inexpensive way of the sharing the software is easy over the internet, and then so we are this is basically helping a lot of people. Personal fabrication things on internet is a different aspect of the Internet of Things as well. So the soft materials, medical materials, is also the important thing. And then if the things are shared, then another problem is the intellectual property and product liability things. But this is RFID printed into the things with a 3D printer, so that anything printed can be uniquely identified by the NFC RFID readers, and then of course referring to the database, so that any printed material is going to be also identified, and then this is going to be helping for the product liability things, because each of the things can be so we call it QIP, quality control, intellectual property, and the product liability for the things generated from the internet. This is NFV, SDN, WebRTC. This is all familiar words for the networking thing, but maybe not on the glass to glass. It's a camera to the things. And the TV is a camera, and the TV screens are going to be very interesting. But before getting to that, then the protein calculation large scale was done with PlayStations around the world. That was the Guinness of 2007, which is the computers. Game is a thing. It's a computer really, but then it was over there. So this is your countries, not my country. But this was, I heard that collecting from all the viewers' behavior, and they created, won the Emmy Award. So which is basically stealing from the behavior of the viewers. So learning from the human being behavior, and then creating the content. So that's a very new thing. So TV is one of the device on the area. So in Japan, TV is pushing a lot of internet technology and promoting the high-speed internet. Oh, by the way, the 10 gigabps with $100 per month started in June. This is pushed by TV subscription thing. So this is probably going to be a last example. This is very hard for you to understand. Maybe the cell phone companies collecting all the data with a registered subscription data, because it's a postpaid, and then generating a lot of data. This is coverage is everywhere, and a very small ground station scale, and real time. So this is a very important big data to be analyzed, and then the people are talking. This is not not allowed, but this is done for the testing purposes. And we found out that the earthquake expecting on the Tokyo area, then we can be an evacuation process, and all the people commuting from all over the neighbor prefecture to central Tokyo and going back, and then we can immediately identify that what kind of a move is happening in Tokyo, and therefore we can prepare for the earthquake disaster things. So this is also benefit risk. I mean, privacy risk is there, but the benefit is there. So there is an anonymization algorithm generated from the learning from all the national survey algorithm about the privacy things, and then we are utilizing it. So this is a lot of architecture with the NFB and the cyber physical things, as Chris said, and also the last three. There is a last week. Then one of the law group is very large actually. They collected more than 700 people 2 days, so more than 1,400 lawyers worked together to discuss about the new principle of IoT, big data, robot, AI type of things they started to discuss. So it's going to be very interesting. So this is again this slide, and then it's really important that the risk benefit balance, but a lot of actual things are happening. So thank you for listening.
Okay, thank you for that, June. Very interesting what's going on there. And now we're going to hear from Professor Luis Munoz, who comes from Spain. He tells me he's from Santander. And he is going to talk about what he calls massive IoT deployment. And when I heard that, I thought, oh, maybe we'll be dealing with billions of devices, but he's probably ahead of most other people. He's talking about, what, tens of thousands, I guess. And so we'll hear about what's going on in there. And then if we have time, we'll take a few questions after that. Thank you.
Thank you. So let's start the last talk. It is a pity, so it's the last one. So I hope not to be too long in the discussion. The talk on the massive IoT deployment on the city at the city scale. So the idea is that I will be providing you many of the details that have been covered in the past by the colleagues in the previous presentations. Indeed, the point is that also I change and I try to fit to the, let's say, to the comments that have been provided with very nice and interesting ideas, and to see how all these ideas, in a certain extent, are accommodated in this concept of a smart city, relying on a huge population of IoT devices. So what is the Smart Santander project? This is a city-scale experimental facility. So we have started as a city-scale experimental facility, let's say, supporting the research and experimentation in terms of IoT architectures, services, etc. So the important point is that, and I would say that the differentiator factor at that moment, 5 years ago, was that besides, let's say, deploying an experimental facility, from the very beginning, we conceived such facility as also supporting in a concurrent way the service provision to the inhabitants, to the municipality, and to the different stakeholders. Before, let's say, starting the real deployment, we made an analysis of which were the characteristics in terms of which are, let's say, the experimental facilities which were available at that moment. You can see here some of the KPIs, some of the metrics that can allow us to assess about the main hints on the experimental platforms. So issues such as heterogeneity, concurrency, mobility, repeatability are key characteristics in terms of deploying, conceiving an experimental facility. Beyond that, and based on the fact that we aim at having such a deployment in the framework of a city, and beyond, let's say, trying to cope or trying, let's say, to implement an omnidirectional pattern in terms of the KPIs, a very important factor a new dimension was the sustainability. So one of the main problems that we were discussing also with the Commission is that beyond, let's say, the life of the project, most of the experimental facilities, let's say, expect problems in terms of sustainability. So one of the key issues for us was to guarantee the sustainability of the platform, taking into account that we were developing such platform, or we were deploying such platform in the framework of the city. So the approach that we follow can be synthesized in these 4 points. So the idea of building an open platform for supporting, let's say, the experimentation on top of the IoT technologies, then to provide a set of initial services for the benefit of the city and the citizens. So the idea that we deploy an infrastructure that is going to support, let's say, the needs, the present and future needs of the citizens. This is an important aspect because in a third derivative allows to foster an innovation ecosystem. So we have realized, and later on I will come with some details, how things change by the fact that an aspect like, let's say, the technology deployment and the fact that the citizen is involved in this sphere of technology makes the city and the citizens feel in a better position and also suffering the criticism of the citizens. So this is just a slide making familiar to all of you with Santander. Many people think in Cantabria like Calabria in the Italy. This is not the case. We are in Spain, and we are not in the south. We are in the north of Spain. So this is a small city, but has been quite active in the last 5 years in the smart city arena. The deployment that we address had at the very beginning a twofold objective. So the first one was to provide an IoT deployment, massive, what is called, we call at that moment massive IoT deployment. So now, as Bob said just before, we are discussing about billions of devices. And the second important point is, besides having this infrastructure for supporting the experimentation, as I have just said, also to provide services for the citizens, but also services for experimenting on top of them. The last point that has been attracted a lot of attention, let's say, in the last 1-2 years, is the concept of co-creating. So how we can embed the citizen in this domain. Now we are in the process, I will explain at the end of the presentation, of this concept of co-creation. So how the citizen participates in an active way in creating the technology, in creating the services. This is the architecture that supports the Smart Santander concept. This is an architecture fully operative. Now it's being migrated in the whole, let's say, fiber concept that also I will explain. So the main points is that we are supporting in this plane the experimentation. So the idea is that we have the possibility and the ability to experiment on top of individual devices in an open approach. The second component refers to the service ability, to the ability to experiment in the service plane. So the idea that relying on the IoT devices deploy, the citizens, not just the companies, the research centers, etc., can design and assess new services relying on such technology. And last but not least, we have also provided the means for interacting the technology and the traditional services with other components like the social networks. So the idea of having semantic tools for identifying particular hot topics in different areas in the city also are managed by this third component. Here I present some of the examples in terms of the technology that has been deployed. We rely in all the facilities around the city, so the lamppost, the facades, the streets, but also we rely on the mobile devices, on public mobile devices, such the buses, but also the taxis, vehicles for parks, etc., etc. So this is the architecture that is being supported at time being in terms of infrastructures, cellular infrastructures, even not cellular infrastructures, or let's say more cluster-oriented infrastructures like the Sigfox one. And a nice example, I think that is better to present a picture, is how, let's say, the deployment looks like. So this is, for example, a noise sensor which is capturing real-time data for measuring how the noise is behaving in different points in the city. I will provide an example of how this initial experiment, the fact that we deploy around 64 low-cost sensors, later on became a key tool for making decisions at the city management level. Coming back to the presentation, these are also some of the examples in terms of additional services. So we have, besides having the typical and the traditional underground parking areas, we have, as you know, lots in the surface of in the streets. And one of the main problems is, as most of the cities experience, is that there is a lot of demand in particular areas during the day. So the traditional way in which that was managed is that the drivers were turning around an area trying to find the place that was not possible. Finally, they ended by parking in the typical underground area. So 3-4 years ago, we started to deploy wireless sensors in the streets. We started with a bunch of around 400 sensors. And now the whole system is managed in an automatic way. So the idea is that even the responsibles for managing the system, they have acquired new skills. So before having such approach, they were using a paperwork approach. Now they use ICT techniques, ICT tools for creating the statistics, for designing the new needs in the future according to the present demands in different areas of the city. We also cope with the integration of new wireless sensor technology with the legacy one. So in the city, we had the traditional magnetic loops. So those traditional magnetic loops were providing the intensity in different areas in the streets, and we complemented such information with sensors at the entrance of the city, and that allowed to create a predictive model of how the traffic would behave in time frames of about 5 minutes in different areas of the city, alerting to the drivers on which areas or which directions should select in a prioritized way. I want to insist that this is behaving in a predictive way, not in a proactive way, not in a reactive way. This is important. So the environmental monitoring, as I mentioned before, so we deploy sensors for monitoring different air quality parameters. But the fact that we could not just rely on fixed sensors due to a trade-off between the extension of the city and the budget, we complemented such information with mobile sensors. And this is the reason for having these buses with, let's say, sensing capabilities for measuring traffic in different areas of the city. So this is the real-time map, for example, measuring, let's say, which is the status in terms of NO2, ozone, etc., conditions in different areas of the city, complementing the ones which gathering such information downtown with a fixed approach. So noise is an important issue, and 3-4 years ago, 3 years ago, once we deployed those sensors, we deployed just based on our, let's say, experience. So in the sense that, okay, that could be an additional parameter to be monitored. But what happens later on is that European regulation made compulsory to deploy or to create the noise maps in cities above 100,000 inhabitants. So what we did is to reuse those sensors for creating in real time the corresponding noise maps. And an important aspect is that those sensors are low cost. Low cost in that case means 1, 2, 3 euros. And the main issue is that those sensors are not compliant with what is called Class A sensors, high accuracy, etc., etc. So what we do is we integrate the values that we are gathering from those high-cost sensors with those deployed all around the city. The problem is that creating a noise map with Class A sensors is not really feasible. We are discussing costs about more than 10,000 euros per sensor. This is not realistic. And the noise map that is created based on these few sensors is not a map which reflects the real behavior of the city. So here you can see this is how we are building in real time the map, interpolating the values that we are gathering, creating a grid or a mesh of sensors in the city, and this is the evolution of the sensing component during, let's say, around 1 hour, compressed here in less than 2 minutes. So the different noise sources that allows to create the map in different areas of the city. So an additional important aspect is the participatory sensing. So 3 years ago, we started with the participatory sensing approach, involving the citizens in the sensing in sensing the city. So now we have a population of more than 10,000 inhabitants contributing in a proactive way to the sensing, but also to reporting events in the city. So the incentivization approach that we follow was the following. So we were interested in having sensing measurements from the citizens, but we needed to incentivize them. So what we did is we developed an application which is called the Pulse of the City, the Pace of the City. So this application allows to the citizens to report events happening in the city, traffic jams, accidents, waste management problems, etc., etc. And the only requirement that we impose to them, always in a voluntary way, is, okay, so we will really be glad if you share your data from your smartphone. And this is the way how we are gathering data from the smartphones in an based on an incentivization approach. So the idea is that we are coming, as you can realize, to this concept of an IoTized, what I call IoTized city, in which we have services, we have an experimental component, we have the citizens, and we need to manage such ecosystem. So the idea is that from around 2012, we make a decision, and that was an important decision because 3 years ago, fiber was near a no, I would say. From the very beginning, we supported the idea of migrating, not migrating, but integrating the whole platform with the firework platform or the firework concept. So the instantiation of such a firework concept is represented in this picture. So the idea is that we have all the vertical services running on top of the firework platform. We rely in particular on one of the key concepts in firework, which is the context broker, which provides contextual information, events happening in real time, plus the historical data relying on a Hadoop file framework, which is called Cosmos. Besides supporting in a concurrent way the services supported in the city, the experimentation, we also support the fact that experimenters, external experimenters, might have the interest to work on top of such infrastructure. And this is, I would say, the slide which reflects how we have converged all these different ideas in one platform, which in parallel guarantees the interoperability. So based on such platform, we are supporting different experiments, not any kind of experiments, but several kind of experiments, and these are some of the nice experiments that have been proposed either in European projects, either by the citizens. This is one which detects the presence of an ambulance. So we have placed sensors with high computational capability in concrete areas, for example, near to the hospitals. And once we detect that an ambulance is approaching, we actuate on top of the lights, giving the priority to the ambulance. But a citizen proposed to use such sensors for detecting the graffiti guys, because you know that the graffiti guys, before they're starting to paint a graffiti, they shake the bottle, and then this is the typical noise. So the idea of triggering an alert for having the guy running out from the area. Another interesting experiment, not experiment, this is an European project. So we reuse the infrastructure, embedding sensors which allow to measure the electromagnetic field coming from the base station. So the idea is that we are measuring in real time the magnetic field, the electrical field coming from different base stations based on a dosimeter that has been deployed in those areas. So this is important because it allows to balance the traffic in different cells, to characterize how the electromagnetic field is impacted in the citizen, etc., etc. This is one of the first, I would say, extensive pilots measuring EMF at the European level. Just for ending, we are in the process of building new cities. Based on the experience that we got in the last year, so we believe that cities in the future will be autonomic. So the same concept of autonomic that we use in the networks, in the communication networks, we can apply to the cities. But for that, we need to have a holistic view of what is happening around the city. And one of the key enablers, at time being, that we are identifying is this concept very well known of semantic interoperability. We believe that based on the creation of this knowledge in the city will really operate not just in an autonomic way, but also in a predictive way, which is the final aim of the managers of the city. And this is one of the first steps in such semantic interoperability, not because it's one of the first projects, this is far from being one of the first projects, but it's one of the projects that tries, besides having the citizens involved in the creation of knowledge, in having new skills, also in promoting this semantic interoperability between cities, aiming at having this predictive approach. So with that, I conclude the talk, and thanks for listening. Thank you very much.
Okay, so we have time. We're going to quit at 5, and you have a 10-minute wrap-up. So it's yours.
Oh, you don't want to do any Q&A now?
We have time.
We have time for some. You want to do Q&A?
Yeah.
10 minutes. Okay, so can you get the panelists up? Let's do it. Okay. So I would like to start by asking any of the panelists, if we actually were to achieve some of the dreams that you have for moving to an Internet of Things, what kind of monies are we talking about per city for, let's say, a city of 100,000 people, or scale it up from there if you like. Maybe it doesn't scale linearly. Are we talking about hundreds of millions of dollars per city? Are we talking about tens of thousands? Are we talking about normal things that people buy in their everyday upgrading of things? Anybody want to take a crack at that?
So you mean in terms of saving?
No, money spent to become an internet-enabled IoT city.
May I? So in this, at least for, I mean, the initial investment that we got, it was for let's say, for such a deployment in terms of equipment, right? So it was less than 1 million euros.
For the whole city of Santander?
For let's say for an area of around 6 square kilometers, which is downtown area. Okay, the city has an area of around 36 square kilometers, right? But based on the fact that we were, let's say, deploying using mobile devices, more or less with less than 1 million euros.
And
in terms of just equipment, huh? Of
the set of functions that you can envision, would you say that got you in your pilot 1% there, 1/100th of 1%, 50%? I mean, I'm trying to gauge what you get for the $1 million.
So, for example, in energy saving, for the public street lighting, the budget that is allocated to a city as Santander is something like for 10 years, something like, let me think, is around 40 million, yes, around 40 million euros. And we have experienced saving of more than 85%. In the sense that now the manufacturers, the business plan that has been already approved is that the saving coming from the energy is going to be paid in the first, let's say, iteration to the responsibles for the deployment of the new LED technology.
So you're basically saying that this will pay for itself on an ongoing basis, and maybe we don't need measures of how much it'll cost, we just get savings back? June, do you want to comment?
Yeah, well, actually the examples I showed, like, those are data collected from the cellular phone companies, and then that was zero, right? It's automatically generated from the cellular phone owner and then the cellular phone company. So no special investment for the special sensors, but it's collected from the business data. And then for the Netflix things is also the same. It is automatically collected data, and then that's generated the revenue to the companies. So automobile companies, actually all of the companies, not only the Japanese companies, they are collecting all the probe data and then collected the data from your automobile to support, to do the services to you, to support your drivers and the owners of the things. So once their data to be utilized, and it's not the additional investment for the the kind of traffic management and other things. But that's weather sensing as well. So in addition to those infrastructural investment of the public authority, then the private data can be collected now to be utilized for the thing. So that's a point I wanted to emphasize.
Okay, thank you.
There are several examples. One that's particularly striking. The city of South Bend, Indiana, had a flood management challenge, right? So flooding of the city was an issue. They approved a $100 million bond effort to replace the water management infrastructure throughout the city in order to manage that flooding. But in the meantime, they had been working with faculty from Notre Dame on smart water management strategy. In fact, they implemented that strategy, cost them about $10 million to implement that. So they saved $90 million on their floodwater management project, which they could spend for other things that the city needed. In Chicago, Argonne National Lab and the University of Chicago are working with the city to deploy multimodal sensors of the type that you were talking about, Louise, to a significant part of the downtown area. And that deployment is being done as part of replacing the light fixtures with LED units. And the combined total for the lights and the sensors being deployed, each sensor is about $40. The return on investment, the time to achieve return on investment is estimated at 2.5 years. So very quick turnaround because of the energy savings and the truck rolls that are saved with respect to lighting. So it very much depends on the structure of the project, what costs you're replacing, and what capabilities you're taking advantage of here. And so it's not at all what I would have imagined going into this area.
And my guess is we'll be surprised further because it almost never turns out the way you predict when it's that kind of a change. Do we have time for a question or two from the audience? Okay. It's kind of hard to see if there are questions. I see one over here. We'll take 2 questions and then I'll turn it over to Vind.
Hi, Takashima Tsuruki to University again.
Can.
Should be on.
Yeah. My question is again about the future or the forecasting near future. You showed lots of sensor network, and based on that, and the probably your system is forecasting what is happening in the very near future, 1 hour later. So how the current technology or how the current intelligence or AI is predicting what is happening and what is the accuracy rate, a good prediction and bad prediction, what is the ratio or the accuracy of the current technology predicting or forecasting what is happening, like congestions or...
So can we actually get models to forecast things based on the data you're collecting?
Louise, do you want to start with that?
Okay, so may I start perhaps? So as I explained just before, so the traffic management map that you see before, you have seen before, is based on prediction. So the typical traffic management applications report what is happening at time being. However, based on the ability to gather data, key data, we are able, and once I mean we, the traffic engineers working in the cities, are able to make the predictions on how the traffic is going to behave. And this is going to happen not just in traffic, but also I was discussing with water management. So based on the fact that sensors are available and deployed in the pipes, and based on the hydrodynamics models for the water, merging both, we are able to predict which is the demand in water in the next 5 hours and to adjust the pressure in the pipes based on the predictive demand. And this is going to happen in all, let's say, the verticals that you might envisage in the city.
Human eye of engineer?
Isa?
The engineer's brain.
Yeah.
Well, actually, those IoT things that we've been talking about is a matter of the scale of the amount of the data is going to be huge, and if that is happening, then the accuracy about the data is drastically changed because of the cost of the data versus accuracy of the data ratio. If you introduce exactly what you said about the artificial intelligence and the other the software intelligence on the data, if the data scale is very large and inexpensive, then the situation of the accuracy is going to be changed.
The savings in South Bend largely come from predictive modeling and doing smart water management based on that. But moreover, we have never had access to urban environment sensing at this granularity. So the urban science that can be done here is just absolutely fabulous. The kinds of things that we just have not had real data to validate some of our urban models and simulations. As was explained, how you get the population in and out of Tokyo in the case of an earthquake. We just have never had the level of data that we can generate with these systems. So the opportunity, I think, is phenomenal for research progress in this area.
So we'll take one more question from Peter, and Vint, if you want to come up here, we'll just stay here and while you do your wrap up.
I just have one question. Do you find some of the data on things like noise, pollution, water quality is actually quite sensitive data? Have you found any problems in making that available to the citizen or to each other? Because it obviously has political overtones.
Well, I mentioned in my presentation that the authority, each of the pieces of the data generated from the what we've been working on as a test, it was claimed by the data authority of each of the segment. The environment authority was very much complaining that when we are, each of the individuals sensing the water quality of the nearby, rivers, and then the traffic data is basically hated by the police department, and so it's always a conflict for the start point. But then they're going to learn that this accuracy of the data is different from the zone data or infrastructure data is different from the mobile data. Then after they understand, then we are now working together.
Peter, you're absolutely right. The first question, the number one concern that I hear from mayors who are talking to us about opportunities for smart cities, the number one question is privacy protection. It's not cost, it's not feasibility, it's not even cybersecurity, which you would think would be, another big one. It's privacy. In what ways, are my residents going to feel that their privacy is being abused here? And so, privacy by design. The answer to the residents has got to be a description of how the design, as you were describing, provides for privacy. What have you taken that into account as a first principle for engineering? What are the engineering solutions? What does that mean to me? Is privacy a top priority, and how is that going to be affected? So it's a hard problem, but it's number one on the list for the mayors.
So I think we need to wrap up. First of all, please join me in thanking this final panel. Second, only an idiot would try to summarize an entire day's worth of conversation. So let me, however, mention one-word summaries of a few things. One, risk. We kept hearing that. Trust, abstractions, simplification, scaling, repurposing of information, integration, strong authentication. Okay, that's 2 words. Legal frameworks, safety. We didn't hear enough about safety today. We heard a lot about privacy and security. My guess, based on what we've heard today, is first of all, this is going to happen whether we want it to or not. The experiments are already underway. Businesses are being built on these ideas. And so we are going to live through some of the nightmares and some of the excitement that we've heard about today, some of the positive values that will come out of gathering data, allowing devices to talk to each other, cars to discuss who's going to go through the intersection next, as opposed to the macho crazy person who insists on going through the red light anyway because it's his street. So I think that what we will experience over the next decade or so is in fact going to be a whole series of incidents, some of which will surprise us, as Bob points out, some of which we have anticipated, and some of which will be completely unexpected. The most valuable thing that this session brings to me is learning from each other's experiences and sharing of the exploration of this landscape of ideas. And so today, I think we've got quite a dose of what's to come in the future. And I think everyone in the room feels an opportunity, or should feel an opportunity to engage. So that's my little summary for an entire day's worth of fascinating stuff. I want to say some thank yous to 2 people, especially Hattie Hamlin and Shannon Green, who actually put this thing together, and Peter Kirstein, who drove the agenda. And so, Peter, you did a wonderful job of that, and I want to thank all of the panelists. These things. Now I want to thank the Internet Society for doing the streaming video part, and I hope on the back of your brochures you'll see that British Telecom and Cisco and the Internet Society have been sponsors of making all this happen, and we thank them for that as well. I have some prizes to award, and that is to the Young Scholars Poster Prize winners, and so may I have the following join me on the stage. Kyle Bottrill from the University of Southampton, who's done an all-optical phase and amplitude regeneration of complex communication signals. There comes Kyle. Next, Adam Funnell, or Funnell, I don't know which, at UCL, a high port count, low latency optical switch for data centers. And finally, Cleomenes Kativas, who did work on a sensing kit, a multi-platform mobile sensing framework. So all 3 of you, please come up on the stage. Where's the photographer when we need? There you are. Let's congratulate all. Please come on up here. Let's congratulate all 3. And we have one more. Do you want us to move over this way? We have to thank you for vacating the page. We need to do this so that we can record this event. So, Kyle, there you go. Very much. Congratulations. Then take that with this hand, and we'll shake with that hand. And finally, good for you. Congratulations to you. And that, ladies and gentlemen, concludes today's conference on the Internet of Things, 5 minutes before the planned schedule. So thank you all for coming. We'll see you on the net.